So tomorrow, no, we would like you also come and speak up something about whatever, like the further topics are about distributions and all those things. So even if you people or your computer or civil subject also doesn't matter, even we will learn civil something. So whatever, like you just come here and take for 5 minutes that this is the topic and I would like or I have taught this topic in this way. So everyone, it will be nice. Kya manta sir? If they come for 5 minutes tomorrow, and they can share their experience that how any topic which you want, from probability statistics or differential equations. So you take any topic which you want, like normal distribution for example, or in differential equations, whatever. This is the topic, this I have taught, or this I am planning to teach in this way. So even if you will share your experience, it will be good. Maybe in the tomorrow's second half, maybe, so that we may think of doing that exercise. It will be completely volunteering. We won't call anyone, provided no one comes. Okay, so now the plan for this remaining 2 hours is I will speak for around 40-45 minutes. Then sir will speak for around 15-20 minutes. And then Sonone sir will start with differential equations for remaining 1 hour. So that's what the plan is for remaining 2 hours. Okay, so we were looking at how to look at the concepts. And we saw how one can think of introducing mean, median, mode, variance and standard deviation. So this is one of the way of introducing the topics which students have already studied. Okay, so that was one of the view. The next topic is coefficient of variation. So what is it? Anyone would like to put some light? Why do we teach coefficient of variance? Those have already taught. Yes ma'am.
If you want to compare two set of data, then we use coefficient of variation. It gives us which data is more stable.
Correct. So like the sir which one give an example, the probability of boys, 7 boys out of 10, there were 7 male out of 10 students, 10 kids or 10 children, and in one village there were 5 lakh out of 10 lakh. So can you say that which one is good or how much is the variance and all those things? So when the data are differing a lot, you cannot just compare two things. So if I want to compare them, what is the tool? CV is a tool that helps us for comparison. Okay, so I hope you got my answer. The example which sir took, you can take that same example. Okay, so how to find that? It is nothing but the standard deviation upon mean. So the core problem that CV solve is the scaling problem. Okay, so whenever the scales are different or when the scales are huge, in that scenario you can always use CV to compare that how much the data is changing or varying. Okay, so for example you can look here. Suppose there is a microservice A whose response time has the following data. The mean is 50 milliseconds and standard deviation is 5 milliseconds. Whereas the database B has query time of mean 5000 millisecond and the standard deviation is 500 millisecond. But now we have to see that which has more variance. But looking at here is difficult to say. You can't say that is a smaller number, so it has a small variance. Okay, so if we have this huge data and if I want to compare between two systems, so that's what the question is. Which system is more variable or inconsistent, you can say. So if you just look at the standard deviation, database has 500 millisecond and microservice has 5 milliseconds. So from here you can see that at least by looking at only the SD, by not considering the mean, you will say, oh, database has 500 millisecond standard deviation, so there you have more of a variance, whereas the A has less variance. But that's not the scenario. Okay, so let's wait and find the coefficient of variance. So if you find for that of a microservice, it will come out to be 10%, and for B as well, it is 10%. So they are equally variable relative to their scale, and that's what the meaning of relative is. Okay, so relatively they both are equally varying. Okay, so that's the reason of mentioning this slide is whenever you want to compare, coefficient of variance is a very important thing because you always have the different numbers, and just by looking the numbers is a small or big, it's not a good idea to compare. That's why coefficient of variance is a very important tool to if you want to compare the relativity or the variance between the scale. Okay, so that's the CV. So that's what I said. You can't compare SD when measures are on different scales. For example, comparing milliseconds versus seconds, comparing bytes versus gigabytes and all those things. See CV, if you observe, what is the unit of CV? I'm taking the ratio, standard deviation and mean, they both have the same unit, it get cancelled out. Okay, so that's why you can see, even if you want to compare milliseconds versus seconds, you have some data where the standard deviation is in milliseconds, you have some data where the mean and the standard deviation is in seconds, and if you want to see which one is more varying, that's time this topic will help you, or this concept will help you. Okay, so whether you are comparing bytes versus gigabytes, still you can use CV. You are comparing CPU percentage versus memory, still is a very important topic. Okay, so people, that's why always prefer the same unit or the unitless quantity. As I said in the last lecture, correlation. People mostly use correlation as compared to covariance because it's unitless. Okay. Scale independent measure of variability, as I said, CV gives you a scale independent measure. Again, like you have three services, it's a practice problem. A spelling mistake, kindly ignore the spelling mistake. Server A, server B, server C, and then using CV you can compare which one is highly variable. Okay, so anyways, not a homework, but you have n number of systems, and if you want to compare the variability, CV will always help you. Okay. Yeah, important topic, random variable. What is random variable? Yes, ma'am.
Variable which can take random values, but domain, it should be from within a domain, fixed domain.
What is the domain for a random variable? The sample space, the collection of all possible outcomes. So why the word random variable? Because it can take random values. That's what your answer is. Any other answer?
Random value by chance.
By chance.
It will be valued by chance.
Okay, so the values that it takes by chance. Okay. Any other answer anybody wants to give? Why the word variable? Like we always take variable x as a variable. So many people have said that it's a function. It's a function, it's a real valued function x whose domain is the sample space. Real valued function means what? X is a function from sample space to real numbers. Okay, so domain is a sample space, my output is a real number, so it's a function. Then why I am calling it as a variable? That's the first question one should think of. I will give you the answer in a moment. The answer lies in probability distribution, but I will come to it. And random, because, so I just want to clarify one thing over here. Usually we say vaguely that it take random values. Actually that is not the case, that what I feel. Why I feel that? Because what is random variable? It's a function. It's a function means you are assigning the number to the inputs. Okay, so it becomes deterministic now. It is no more random, because once I am saying a function, I am giving, like for example, you can take tossing a coin 2 times. What are the possible outcomes? HH, HT, TH, TT. And then you assign numbers to this outputs, right? So now this becomes a deterministic thing. You have given the things. What is random is when you perform an experiment, the output is random. That's what my way of looking is, because once I'm saying something is a function, it becomes deterministic, because function means what? You have defined something. This will have this output, this will have this output, this will have this output. You are defining something. Randomness कहाँ से आता है? Because the experiment is random. Like जैसे कि you can think of that vending machine जो होता है, there's a vending machine nowadays, airport or wherever you go. When you press 2, the juice will come, that is for sure. So randomness is not what is going to come, randomness is what I am going to press. Function is already defined, for 2 chips will come, for 3 juice will come, for 4 chocolate will come. Okay, so outputs are always defined for that input. What is randomness? What I am going to press, because someone will come, he is going to press something. Randomness is there. What will be the outcome? I mean, when you do an experiment. So experiment is what I am going to press. What I am going to press, that is random. But what output I am going to get, that is already fixed because of a function. So you are getting what I am trying to say. So that's how the randomness is coming. And variable, because you have, everyone has taught probability distributions. Okay, what is a distribution? You look, okay, I will come to it later on, but anyways. So you flip a coin 3 times. What are all possible outcomes? How many possible outcomes? 8 possible outcomes. Okay. So these symbols are letter. Now why? What is the need of random variables? See, we are already teaching a definition of a probability, and which is in terms of function, the modern definition of probability. We already have one function. Why we are introducing one more function? random variable. The problem is it helps us in whenever we have categorical outputs. Okay, that's why we need random variable, because random variable क्या करता है, it assign those outputs to numbers, and as soon as I have numbers I can play with the expectation, the variance, the distribution and all those things. But if I tell you the output is head and tail, how do you find the average? How do you find the distribution? Okay, so whenever you have categorical outputs, HT, HHTT or so yeah, for such things we can't find the average, we can't plot the graph, we cannot do mathematical operations, we can't do calculus or algebra. Okay, so that's why we have random variable. So how many heads did I get? Now that's what a number is. Now once I have a number, you can calculate, you can plot, you can analyze. Okay, so that's what the random variable does. It converts the outcomes into numbers, and then we can bring all of our mathematics into it. Okay, so students, why I'm putting so much stress on random variable is it's very important to convey what is the role of random variable. If you just say it's a function x from omega to r, the sample space to r, it feel nahi hota, as I said, you should feel it, right? So if you want to feel it, you should say this is what it does. It assigns numbers to the categorical outputs, if the sample space has categorical outputs. And once you have numbers, you can do all your mathematics. So that's the role of random variable. So as I said, think of a data conversion in programming. So before random variable, you have a data in unstable format, strings. As I said, it can be head, head, tail, tail, whether the item is defective or not defective. Then you assign a number. If it is defective, you give 1. If non-defective, you define 0 or other way whatsoever. Okay. So random variable क्या करता है? It puts the data in numerical format. That's why random variable is so widely used. Okay. So that's the importance of random variable. So let's start. As I said, you should always start with a classic example. So let me start with a classic example. Everyone knows that if you flip a coin twice, these are the possible outcomes. Each is a fair coin. So outcome is 1/4. Now you can define many random variables on a given experiment. In this case, I am defining x to be the number of heads. You can define it number of tails. You can define number of 2 heads. You can define it as number of 3 heads, whatsoever you want. One can define n number of function on a given sample space. And then you can see these are the outcomes. Now what is the output? Now as I have seen, it becomes a deterministic. It's no more random. I know that once I define x, the number of heads is deterministic, that HH ka value is 2, HT and TH has value 1 and TT has value 0, is fixed. What is random? When I perform an experiment, what output will come? That is random. Okay, so this is randomness, this is deterministic, these are fixed. Once I define x, this becomes fixed, and then probability is 1/4. Okay, so that's how one should make sure the concept of, because random variable they will be using a lot. Okay, whether in random processes, Markov chains, queuing theory, reliability theory, everywhere randomness is going to come. So the concept of random variable should be clear. That's a very important thing. Okay, and now you can find the probability. Now if I would ask you what is the probability, earlier we had TT, HH, HT and TH, but now we have assigned number to it, so I can now find the probability. What is the probability that x will take the value 0? So what is the range for x? The range for x is 0, 1, 2. The range means the possible outcomes. Okay, so the range is 0, 1, 2. Now I can find the probability for 0, then I can find the probability for 1, and then I can find the probability for 2. So now you can see, if p is a function, these are the inputs, that means it's a variable p of x. Okay, so now for this function p, these are acting as a variable. So when I'm looking for the probabilities or the probability distribution, the range for x, they become the variable for the function p, and that's why the name variable. That is the reason we call it as a random variable, because for probability distribution, the output, they become the input for this probability function, and which is a variable. So that's one way of, because when I studied random variable, when I saw the definition, it's a function. See, I never learned probability, neither in my BSc nor in my MSc, never. But when I taught to engineers, it's obvious that why the random variable? It's a function from omega to r. Then why the word variable? Why the word random? And that time then I googled. That time there was no chat GPT in 2016. But so I googled, and When I saw a couple of links, this is what I could interpret, that this is what you mean by a random variable. So this is the probability distribution for x equal to 0, 1, 2, 1 by 4, 1 by 2, 1. And now you have this, so now you can do all the mathematical operations. You can find the expected value, you can find the variance, you can plot its probability distribution function, and you can do all those things. Okay, so the main takeaway from this is you should be clearly define what is a random variable. Okay, don't just say it's a function. Then simply say function. Why random and variable? Randomness because of the outcomes, variable because whatever the outputs you are getting, that will act as a variable when you try to plot the probability distribution. Okay. Now, as I said, after classical example, you should go the domain or the field related example. Okay. So suppose there are network packets. So what is the scenario? You are sending a packet over a network. So once you send a packet, either the packet will be delivered, or it will be lost, or it will be corrupted. These are the three possible scenarios. Now what I am doing on this, again it's a random experiment, because we know these are the three possible outcomes, but when a packet is sent, we don't know what is a random experiment. It's an experiment where you know all possible outcomes, but when you perform that experiment, you don't know what will be the outcome. Like tossing a coin, you know what are the all possible outcomes, head or tail, but when you perform, shole ka nahi hai, it's a fair coin. Okay, so you don't know what is going to be the outcome. Okay, so you know when you send a packet, these are the three things which is going to happen. Okay, so I'm defining a random variable as a delivery status. So if it is delivered, if the packet is delivered, the output is 1. If it is lost, 0, corrupted, -1. So this is one way of defining the random variable. And as I said, why does it help? It helps us to find the success rate. If I want to find the success rate, what will I do? I will just find the probability at x equal to 1. Success means what? The packet is delivered. Okay. So because of this conversion, now you can easily find the success rate by simply finding the probability. Okay. So from statistics, ultimately we have come into the world of probability, and very smoothly. Alag se probability, I never defined probability alag se. Okay. So very smoothly we have come from the world of, I don't know how many of you realize, when did I first use the word probability? Yaad hai kisi ko? And the transition was smooth. That's what I want to say. You should always do the transition between one concept to another concept so smooth कि अच्छा ये पढ़ा भी दिया, with understanding obviously. So that's just what I think, and you can track the performance over time numerically. What are the types of random variables? Discrete and continuous. Discrete as in very standard. So discrete means it takes the countable values, you can list them, and then again examples. Again I have taken the field related examples. Okay, number of servers that crash, either 0 server can crash, 1 server, 2 server, number of API calls per second, number of bugs in the code, HTTP status code. Okay, so all these are examples of a discrete random variables. So as I said, if you're teaching computer IT people, always take the field related example. I mean, I forgot to put one non-field related example, but it's okay, that you can do it. Okay, so it will always be helpful to you. And continuous means what? It can take any value in the interval. Response times, CPU temperature, downloading speed, disk usage. I mean, everyone knows this, so I will not spend time on this. Now comes a very important thing, PMF and PDF. Okay, what is PMF? Mass function. PDF probably. Now again you can give some motivation, why the word mass and why the word density. Okay. Today's bedtime reading topic, why the name PMF and PDF. Okay, think over it. I will tell you tomorrow, but I want you to think over it. How do I describe my data? Now you have collected 10,000 API response times. Your manager asks, describe the performance. Okay, what do you say? Will you list all 10,000 values? No, that's not possible, right? You won't be listing all the 10,000 values. Just give the average. Not enough, because you don't know what is the response times for all those 10,000 APIs. Okay, you show the distribution, and once you show the distribution, you can see the graph, you can visualize. Once you have graphs are the best way to visualize the things. Okay, so the compact way to describe how the values are distributed, and that's what PMF and PDF does. Okay, so suppose I'm defining the random variable x as API response time. So instead of listing 52 millisecond, 52, 48, 51, 49 and so on, we describe 70% of the request take 40 to 60 milliseconds, 20% of the requests are taking 60 to 80 milliseconds and 10% requests are 80 to 100. And now you can tell the probability. So now this is a much more good way to tell. Okay. So between 60 to 70, 0.7, 60 to 80, 0.2, 80 to 100, 0.1. The bar vertical graph which you draw for PMF. Okay. So like this, if you have the probability distribution, it's always good or easy to interpret or read the data. Okay. So yeah, what is PMF and PDF? Let's spend some time on this. Sir, what is the time, sir? Time? 2:20. Okay. So let's spend some time this. What is PMF and PDF? Tell me, chalo. You should speak up, no? Otherwise your neurons will make you sleep. I hope everyone has 2 chapatis. Salah, bola. How do you define PMF and PDF in your class? How do you define? Think. How many of you are going to teach this for the first time? First time, probability statistics. Anyone is going to teach in the next semester for the first time? For the first time you are going to teach. Okay. Have you learned earlier? PMF, PDF, probability learned? Not learned. Oh, acha. ठीक है. Others. Also, I have a lot of experienced people then. Chalo. What is PMF, PDF? Give me the definition. No, need to think of any creativity or all. Whatever you think.
Summation of probability is equal to 1.
Probability summation should be okay.
And each of that probability lies between 0 and 1.
Okay, good.
Call that distribution as PMF.
PMF distribution.
X is a discrete random variable.
Discrete random variable. Correct. Correct. Any other? Something different?
सर हम क्या करते हैं
हाँ.
कि जैसे कोई सिचुएशन में क्या होता है कि हम हर रैंडम वेरिएबल के लिए कुछ प्रोबेबिलिटी निकालते हैं, पर अगर कोई एक सिचुएशन है जो सिमिलर कंडीशंस फॉलो कर रही है, तो फिर प्रोबेबिलिटी के बाद टर्म आता है प्रोबेबिलिटी डिस्ट्रीब्यूशन फंक्शन. अब वो जो भी प्रोबेबिलिटी है हमने देखा कि वो कुछ पैटर्न फॉलो कर रही है, तो अगर वो कोई पैटर्न फॉलो करती है, कोई ऐसी सिचुएशन है, तो हम क्या करते हैं उसे फंक्शन फॉर्म करने की कोशिश करते हैं. और अगर वो फंक्शन अगर वो रैंडम वेरिएबल डिस्क्रीट होता है तो वो प्रोबेबिलिटी मास फंक्शन होता है. पर इफ अ रैंडम वेरिएबल इज डिस्क्रीट देन वी डिफाइन एज प्रोबेबिलिटी x इज लेस देन इक्वल टू x एंड फिर वो प्रोबेबिलिटी डेंसिटी फंक्शन होता है. जो हम प्रोबेबिलिटी पढ़ते थे वो प्रोबेबिलिटी होती थी, अब हम उसी प्रोबेबिलिटी को एक फंक्शन का फॉर्म देते हैं एंड वो सारे रैंडम वेरिएबल विद इन दैट पर्टिकुलर कंडीशन. जैसे कि अगर वो बाइनोमियल को सेटिस्फाई करता है, उसके 3-4 कंडीशंस है, तो बाइनोमियल का एक पीएमएफ है. फिर अगर उसमें हम 10 कॉइन टॉस करें, 20 कॉइन्स टॉस करें, डजंट मैटर, वो एक सिचुएशन को फॉलो कर रही है, दैट मींस दैट विल सेटिस्फाई दैट पीएमएफ.
Okay, so for according to you, PMF is something like you have a probability and you are assigning function to it.
हाँ,
Function
प्रोबेबिलिटी को फंक्शन का फॉर्म दिया है हमने. इट कैन बी लाइक
probability.
She is saying that just touching, I think, things, but not in the word. What happens in PMF that we have the point probabilities.
Point probabilities.
Whereas in PDF, the point probability is always 0.
Why always 0?
So that is why the calculus comes into the picture.
Come in picture.
Because whenever we suppose divide the area in 2 parts, 2 rectangles.
Correct.
And if I say the vertices A, B and C.
Correct.
And then AB is the side, BC is the side. What is the area of this? What is the area of this? We add and we take the area. But what is the area of the strip?
Strip is 0.
Because
Correct.
that strip, whether you are including in one part or the other part.
Correct.
If it is so, then they will not be equal.
Correct.
We are dividing equally. So there is that definition in
Correct.
calculus that
Correct.
infinitesimally small kind of things. Strip
Correct.
area is considered 0.
Correct.
And that is why it is valued. Otherwise
Correct.
it becomes invalid.
Invalid. Correct.
And that's why we take the probability between A to B.
Between A to B.
define and not
Not
at
at
A
B.
or at
Correct. So that's what we do in continuous case. So whatever sir has said, I'm going to say the same thing in more elaborative way, little bit. So before that, let me just revisit again PMF, as many of you already know. So if I take the old classic example which I said, the outputs was 0, 1 and 2. So this was the outcomes of the random variable. Now that is coming over here. And what is my output? Output are the probability of x. Okay. So what was the probability for 0? 0 was x is the number of heads. When I am tossing a 2 coin, head HH, HT, TH and TT. My x is the number of possible heads. So x equal to 0 means what? There are no heads. What was the probability if you remember? 1 by 4. Correct? 1 by 4 is something suppose over here. What about x equal to 1? 1 by 2, right? And x equal to 2? 1 by 4. Okay, so this is the one, what are the graph you call this? So this is the thing you are having. So you are looking at the distribution of the probabilities that your random variables are taking. Okay, so these are PMF, and as you can see, if you add up 1 by 4, 1 by 2, 1 by 4, your answer is 1. Okay, so since these are the probabilities, they are always between 0 to 1, and your sum of the probabilities should be 1. So in general, if I want to define this as a function, what do I do? If you have observed, I don't know, it's always an ordered pair. Okay, given and sample space, first thing is I define a random variable, and for that random variable I am finding the probability distribution. Okay, you must have either seen, I don't know whether you have seen this notation or not, but probability distribution is always defined as an order pair. Like those who have studied abstract mathematics, if I want to define a group is always an order pair. Okay, if you remember, group is always G comma star, because a group always comes with a binary operation. Okay, so like group is like defined as an ordered pair. Your probability distributions are also defined as an ordered pair, because it is always defined for a particular random variable. And how do we define it? As everybody said, your function should be greater equal 0, or to be precise between 0 to 1. Second thing, when you sum up the values of the function as x belongs to x, your answer should be 1. And what is the function? What is the values will it take? It is nothing but the probability that x will take the value. So I am saying f is a function. What is the function? What values will it take? It will take the probabilistic values. The sum of the probabilities should be 1 and the function should be non-negative. Now what I have done is I have defined in general what a probability distribution is. Okay, not just sticking to p, I have introduced a new f. So if you have any random function now which satisfies this thing, is the probability distribution. Okay, so we have generalized the concept. Okay, and what sir was saying, like we get an area from here. Now we can also look as the probability as the area, and that's what I read, stated the connection. You just take the width half and half on both sides. So what you get is a rectangle. What is the area of the rectangle? Length into breadth, which is length into height. Length is 1, height is the probability. So area is nothing but 1 by 4. Do the same thing again, 1 by 2 and 3 by 2. Again the length is 1, height is 1 by 2. So again the area is same as the probability. And here also your area is same as the probability. So one can always look probabilities as an area as well. Okay, and this is what happens in the finite case. Finite as in the discrete case. Now if you go towards the continuous case, what will be the definition? What is the continuous version of summation? Integration. It should be 1 over r. And you can look over here also. Now you have it, your output can be anything. Earlier when x was discrete, it was only numbers. Now it is a continuous random variable. That means it can take any value over here. Okay, so that means you have, those who have learned Riemann sum, you do in partitions. Once you do partitions, the rectangle becomes closer and closer. They come very close to each other, and ultimately you get a curve. So what is the integration? It is the sum of the infinite areas of the rectangles. So when you are going from the world of discrete to the world of continuous, this you have infinite rectangles, and ultimately you will have a curve. And if you want to find the area of an area under the curve, you have integration. So that's how, if when you go from discrete to continuous, we are going from the finite areas of rectangles to infinite areas of rectangles, and whenever you have an infinite rectangles, you get a curve, and that area under the curve is nothing but the integration. So that's how integration is also coming into the world. So one way you can say is the continuous version of summation is integration, or if you have taught Riemann theory in your class. If you have not taught Riemann theory, then you cannot put this analogy. So you can simply say the continuous version of summation is the integration. That's the best way to say. Or if you have taught Riemann sum in your, do you have Riemann sum in your syllabus? No, acha.
At the time of double integration, we explained the small concept that we are taking summation.
Summation,
So
okay.
we are adding it,
Acha.
application of area. So at that time we explained.
That time you explain. Okay. So if you have taught them earlier, you can put this analogy of Riemann sum and how Riemann did this beautiful thing of integration. And yeah, so that's your PMF and that's your PDF, and that's how it's connected with the calculus. And now we can say that how if I have a continuous random variable, I have a continuous probability distribution, I want to find. So now here you find the probability of a point in discrete case, but you can't find the probability of a point in a continuous case. Why? Because you can say the probability of a line is 0, or the area of this line is 0. One way to say that. Or there are infinitely many outcomes. Probability of occurring a single outcome will be what? Very negligible, very negligible. Epsilon times you can say, and epsilon can be in any small. That's why probability of a single point is always 0 when you are playing with a continuous random variable. So that's why we never find the probability at a point when we are playing with continuous random variable. We always find the probability between two numbers A and B. So if this is my A over here, B over here, you simply, if you want to find, you get this to be 1. Is this fine, what I am saying? Okay. Do you know any function whose area under the curve is 1?
e raised to minus x.
E raised to minus x.
Half times.
So minus e raised to minus x.
1 half times.
1 times?
1 half times.
1 by 2 times, ऐसा. But still e raised to minus x now, so you will have minus infinity, infinity. This will be 0, but you will have e raised to infinity. Zero to infinity. In that case, then you will get some finite answer, then you divide by the number 0 to infinity. So you need to define from here the function is 0 and here it is e raised to minus x. Any example? Which example you take? Once you define probability density, do you take any example? That integration of a function is 1? Gaussian function. Which examples you take? Alright. You must be doing improper integrals. Improper integral नहीं करते क्या? अच्छा ठीक है चलो. So anyways, you should always have a couple of examples in mind whose area under the curve is 1. Okay, so one of the very famous is the, as sir said, the Gaussian, the probability density function for normal distribution. Everyone knows that, right? 1 upon square root of 2 pi sigma e raised to minus x. You subtract from the mean, divide by the variance, and this is a probability density function. Okay, so anyways, you should have a couple of concrete examples whose area under the curve is 1. ओके ये हमेशा 2-3 तो भी होने चाहिए दिमाग के अंदर. सॉरी सर 1 by root of 2 pi. हाँ 1 by 2 sigma square. 1 by 2.
Just take one example. Come to its area and then divide that function by that number.
Correct. So that's what. हाँ. So as he also said, no, 1 upon e raised to. So once you get some finite number, just divide by that.
Divide by that number.
How did Gaussian come up with this? ऐसे थोड़ी कुछ सपने से उठ के उसने फॉर्मूला लिखा नहीं. He had exponential, for example, e raised to minus x square. You integrate this from say 0 to infinity. Root pi by 2 is something is the answer, something like that. है ना, root pi by 2 है ना, बरोबर. So he had some examples. He tried to generalize this. इसका integration when he did, तो वो root of 2 pi आ रहा था, whatever root 2 pi sigma whatever, then he divided by that number and it becomes 1. So whenever the area is finite, just divide, you get 1 as an answer. Okay, so no need to learn also. Just keep couple of functions in mind, you get the answer. You must have taught gamma functions. Gamma functions पढ़ा है आप लोगों ने? हाँ तो gamma functions means what? 0 to infinity. बाकी की जगह तुम 0 डिफाइन कर दो, doesn't matter. ठीक है. So Yeah, and then what you do after doing this, you go for some nice distributions. I think this is your unit number 3 if I'm not wrong, or 2. कौन सा unit है आपका ये? 3rd unit. So I'm teaching whole probability in 2 hours. That's good. So PM, yeah. So what is binomial distribution? I thought I would have told you this tomorrow. मतलब you will come, one of you will talk on binomial, one will talk on normal, one will talk on uniform, one will talk on Poisson, and one will, how many distributions you have? Geometric is also there. Negative is also there. उसका स्पेशल केस ज्योमेट्रिक है, उसका स्पेशल केस ज्योमेट्रिक है, नेगेटिव नहीं है लेकिन नेगेटिव नहीं था सिलेबस में. आई कुडंट सी. नाही ते नाही सिलेबसमध्ये, म्हणजे त्यांनी जो पाठवलं त्याच्यात नाही आहे. 4 डिस्ट्रीब्युशन्स आहेत, नॉर्मल, युनिफॉर्म, बायनोमियल, पॉइसो अँड ज्योमेट्रिक 5. ओके. So does anybody want to talk tomorrow on that? I mean, I will also talk. So one of you will talk on 5 minutes and then I will tell my way, you tell your way, I will tell my way. आता डिस्ट्रीब्यूट करायचं आहे का तुम्ही उद्या करणार 2-2चा ग्रुपमध्ये किंवा 3-3चा ग्रुपमध्ये का इंडिव्हिज्युअल सोलो परफॉर्मन्स? सांगा, तुमचं वर आहे, ऑल द फ्रीडम. कसं करणार, ग्रुपमध्ये करणार का इंडिव्हिज्युअल करणार? काहीतरी तर फिलिंग येत असेल ना आतमधनं, बोला.
म्हणजे आता मी टॉपिक डिसाईड करून घेतो.
Yes, sir.
असं वाटत असेल की मला करायचं.
आणखी एक्सरसाइज देणार आहे, ती याच्याशी रिलेट करते.
अच्छा, okay, so we'll come back to this question after 5 minutes. Okay, once sir will come to it. So okay, I think I will stop now, कारण की I want to discuss this tomorrow. है ना, टाइम झाला का सर, किती झालं? ठीक आहे. Okay, so I think that's all from my side. What I want tomorrow is, once sir will also give you some homework to do, you just relate the things, and tomorrow please do come with the feedback. I mean for both of us, I mean it's not for me. What you expect, and म्हणजे सर तर तुमच्याकडनं घेणारच आहे फीडबॅक, पण we would like to listen from you as well. चालेल का सर?
ॲक्च्युली पुढचे जे काही प्रोग्राम्स आहेत त्यासाठी फीडबॅक लागणारच आहे. ते तुम्हाला काय अपेक्षित आहे, स्टुडंटला काय अपेक्षित आहे, असं तुम्ही फीडबॅक म्हणजे रेटिंग नको आहे.
आणि त्यातलं शेवटचं हां हेच मी फक्त प्रेझेंटेशन मोडमध्ये जा. नाही प्रेझेंटेशन मोड आहे ना मॅक्झिमम. तिसरं सिम्बॉल आहे बघा, ते वरचं वर. नाही त्याच्यावरचे, हां त्याच्या आहे, हां ते या. Yeah, we have talked about the mean, variance, standard deviation. Equally important is the concept of expectation. Things can happen, but what is the return you will get if that thing really happen? And this is the key factor in many applications like that. So mathematically, this is very simple definition, but just see an example. On throwing a fair die, you get ₹20 if the face is showing number 2. Suppose this is the rule we established. You roll a die, if number 2 comes up, I will give you ₹20, right? Sorry, if it were, you will lose 40 if 4 turns up. You know, we are playing a game like this, and get rupees 60 if 6 turns up, right? Now, a sort of a game which you can play in the class. Like, remember I say in action. So, action like that, you may not really pay or take like that, but this is how you can generate that. There is a possibility of 2 will happen, 4 will happen, 6 will happen. But if it happens, then how it is related with real life? Just throwing a dice is okay, but now we are giving up some numerical expectation if this thing happen. What is the expected sum of money you can win? Suppose this is the really rules of the game, then you can relate it with probability of everything is 1 by 6 pieces. So if 1 comes up, nothing is expected, so rupees 0, right? If 2 comes up, probability is 1 by 6, but you will get rupees 20, so plus 20. Again 3, there is no payoff, so 0 rupees, but probability remains 1 by 6. Now 4th, you will lose 40 rupees, right? So minus 40 into 1 by 6, 5 and 6 only. So now if you add this, still the sum is positive, 20 by 3, means around 7 rupees, something like this. Now this is very important in real life application, that although the things were related with the dice or tossing a coin, etc., each has got some meaning which can be associated, and from this you can expect. That's why the mathematical term is called expectation or expected value. So with this simple example, you can introduce them to the concept of expectation like that. Okay, I am just skipping all these things. He touched upon this, and you also said 4 or 5 these distributions are there like that. Just see the last term, Gaussian distribution, he said like that, because Gauss, Carl Friedrich Gauss, the prince of mathematicians is called, he did this, so his name is there. But generally people call it normal distribution, right? Or mother distribution. What does that mean? All these, you do it many times, it will form the normal distribution. That's what it's called mother distribution. So these are the curves associated with some of these like that. And I think you will be elaborating tomorrow some of these. So I'm just keeping them. And there are some properties. So examples, how my secretary used to commit errors and then in what pattern they fall, etc. Okay. Then it followed the Poisson distribution. I showed it like that. So it was a real application confined to my office, right? And then verify, really it follows Poisson distribution, like that. Then this is from anthropology. See, what I am trying to say, as is a classic example, subject example, and I am saying slightly go beyond also and show them that this is really useful. Not only for English, but it is really useful. This is totally different anthropology. They never studied mathematics, but the kind of data they got, it was found to follow one distribution, etc. And this is the normal distribution, all you seen. And then graphs. Nowadays you have got so many tools, computer based tools. So how is simple diagram can be put in different forms. That is very important. Nowadays students want to have very good presentation, so they can just convert the normal graphs into the computer aided beautiful graphs like that. This we have seen the same mean, but the standard deviation getting different. Yeah, now this is the story you can relate. this person or myself, I am standing at the bank of a river and I ask a villager there, can I walk through this? He said yes, because the depth of this river is 3 feet, average. And then I walk through there and I am caught. Understand? No. So they understand that something has got wrong because he said average was 3 feet. Now ask them, if this happens, can you construct the data for this story? See, the challenge is here. You understand the meaning. But now, see, just I am showing example. It could be like this. At some point 2 feet, 3 feet. Construct the story. So they are constructing the numbers and its average is 3.1 feet, which that fellow has told me, and I am caught in the river like that. So again, this is the point I am saying, that you make the class interesting, which are with the examples which they can easily construct and enjoy it. So somebody may construct different kind of data like that, but they have to come to the same meaning. So that is how, this is the point I wanted to make like that. So I am just keeping deviation, hypothesis testing, etc. This just very simple example from a medical counseling room. To 9 patients, a medicine was administered. The following increment in their blood pressure was registered. Right? So someone's blood pressure rose by 7 units, whatever they. Some second patient 3, someone's dropped by -1, like that. Was the medicine responsible for this increment? Now this is the question the nurse or doctor has to answer, because he has chosen 7 patients and given the same medicine, and there was a drop or increase in the blood pressure. So is it that medicine is doing it, or there is some other kind of thing happening like? And then you can assume medicine has got no effect. This is the hypothesis you are making, or medicine has got effect, and then you perform Z test, T test and get the result. So hypothesis testing is related with the statistics with real life application. This is the point again I am telling you, that if you do this, then they will find the interest in calculating or understanding the underlying phenomena. So let us not go into that. This is one thing which happened in MMRD when I was working, that my boss was from military background, right? So he showed me this one specific road. He got the data from the field survey. He said on Sunday there were 14 accidents on this road. Then Monday 16, Tuesday 8, Wednesday 12, Thursday 11, Friday 9, Saturday 14. There were totally in that particular week 84 accidents. Then he put his finger on Monday 16. He said, so Monday is the bad day. People enjoy Sunday like me with drinks, etc. Very careless, and so you must do something on Monday. See, this is how you will be facing the challenge. I say, for me, all the days have equal importance or equally good or bad, but you have to confront with your boss, and that too from military. He said, what I say is you have to accept it, that kind of thing like that. So I said, sir, let us see from this angle. Are the accidents uniformly distributed over the week? And I feel that there is nothing special about Monday or Tuesday like that. They are uniformly distributed. So if there are totally 84 accidents and 7 days a week, so 12 accidents should have been the ideal average or ideal mean like that. Then I constructed a hypothesis and all these things, and I say using chi-square test, etc. There is nothing special about Monday, and so do not blame the Monday blues. So very simple example, but it is giving big message that even simple hypothesis formation and making it logical through statistical analysis can win your point. Then the rain forecast. Everybody blames the weatherman. So we got the data collected, and is there any association between the forecast and the observed rainfall? No, this was the data from the monsoon like that. So no rain was predicted, no rain happened. Good. There were so many days. No rain, but light rain happened. No rain and heavy rain happened. Now this kind of data you can easily get. So we did this and tested this hypothesis, and we found there is no association between these two. So just don't weatherman unnecessarily like that. Then taking example from cricketers. So we said that number of fours hit by 3 players while scoring century in 6 randomly selected test matches are given below. Is there a difference in the average number of fours hit by them? So Sehwag, Tendulkar and Dravid. Randomly matches were picked and number of 4 hits were put like this when they scored a century, right? There is no difference, we assume. When they scored century, they score more or less same number of boundaries like that. And the alternate hypothesis, there was a difference like that. So we tested using all this, and we found that there is really no difference. So as far as boundaries concerned, in the century they scored, there was not much difference. But if you had given number of balls taken, then there would have been difference. Tendulkar and Sehwag being attacking batsmen, they would have taken the less number of balls, whereas Dravid was wall, as we call it, he would have taken. So this kind of example, which is really near to their heart, cricket they every day watch like that. But when we link data like this, taken easily, and show them, then they understand the power of this testing. I will just keep it. Somebody will be talking about correlation, then I will talk about this example. So these kind of patterns, correlation. This is a very sociological based example. What is it saying? What is the degree of association between the intelligence in father and his son? Right? For this study, a group was selected whose intelligence measure IQ test was held. So there were 4 outcomes. Intelligent father, you can substitute mother also, and son with daughter also, like that. Intelligent fathers with intelligent sons, 248 out of that group. Intelligent fathers with dull sons, 81. Dull fathers with intelligent sons, 92. Dull fathers with dull sons, maximum number. Right? Now we want to know whether there is this data is showing any association. Our hypothesis is that intelligent father means intelligent son. Right? So whether that holds good or not, sociology, psychology, any field will have this kind of questions. And then we compute, use coefficient, etc. And it shows a strong positive correlation. At least for this data. This is not a universal, but whatever data collect from that particular village or something like that, we cannot generalize this, but this, at least for this group, it was happening like that. So if you increase the study, perhaps some different results can come. So this also you have to tell them the limitations of all the statistics we are using, or any study, the limitations are to be borne in mind while interpreting the results. Then rank correlation, we will just do. Estimation. Do you teach estimation? Statistical estimation? No, anyway. If we get time, I will show you. It is very powerful tool. Okay, tomorrow we will see time like that. Okay. This is another thing. Exit polls, right? And based on that exit poll, they make a prediction. So the opinion poll shows that 35 voters in the sample of 164, right, who have voted, and they said they vote for the party ZZZ, right. So on that basis, we can construct the 95% confidence interval, and that shows that with 95% confidence I can say this party has got 15% to 28% of the voters approval, like that. This is how the psephology has said they work it on this basis, and one can refine it. This also I just keep it. Then regression is required in many cases. I will just skip because I want to give more time to him. But tomorrow we will come back to these kind of things. And then where the statistics is used, the question is wrong, where it is not used. So from A to Z, you take any subject, it is used. From agriculture to marketing, business, engineering, finance, health, even jail management. Now, so many criminals, how much capacity we have to increase. Now, this is uncertain, na? Who is going to commit crime? You cannot predict so easily. So, even jail management, we have to work on some distributions, and on that basis, whether to increase jail capacity, and so many decision is based. A to Z up to zoology, you take anything. Now, this is the exercise for you to consider. Besides those distribution, I am saying construct a data-based example related with the queuing theory. So, Poisson distribution, exponential distribution will come into play. So, just talking about the exponential distribution of Poisson distribution, can you link with the waiting line models or queuing theory? So, someone or a group can think like that, or reliability theory, quality control charts if you want to take up, information theory, a Markov chain and weather forecasting. These are very live examples. Somebody, you can get data even from internet, you can, but make the presentation. So you have understood it, and what are the nuances, finer aspects of that will be very clear like that. And this question, we said mother distribution, normal distribution. What is the significance of that word normal? Question worth thinking. So I will like to get the answers from you. Why Gaussian curve and Gauss, we are giving credit to Gauss, but in normal parlance it is called normal distribution. So why that term normal is used? Please try to think and put your views tomorrow. Somebody can think of logistic distribution for population prediction. Very important tool, logistic distribution. Spurious correlation. Some of those who are taught the correlation, there is another dimension called spurious correlation. Somebody can work on that, or we will take some example. Portfolio management. That's why I talked about the expectation. So, what is the expected if I purchase or invest in these mutual funds or shares, and probability is this like that. So, that is called the portfolio management. So, how whatever you have taught with distribution, expectation can be used to build the portfolio management theory, and PERT CPM, right? So, beta distribution, etc. So, that side you can think of putting it like that. So, I will stop here. So, I think, and one more thing, the golden ratio. Yeah? So, if somebody can talk on these aspects, most welcome. Okay? So, we will continue our discussion tomorrow after your presentation. Is okay? Yeah. Second is this, and last point added is the golden ratio. Okay?
Examination ranks. GATE 2007 All India rank 191, GATE 2008 All India rank 96, and GATE 2009 All India rank 379. Sir has a vivid experience, teaching experience of teaching in Sierra Institutes of Technology and from 2005 to 2008. Trinity College of Engineering in Pune from 2008 and 2009, and since 2010 you are with SPPU, SP College.
SP College, yeah.
So welcome to you, sir.
Thank you, madam. Thank you for your nice introduction.
तो सरांचा घेतला का हा घेतला हा कॉलेजचा हा दोन्ही
हे बंद आहे का? बंद झालं का?
नाही नाही तो आहे ना कॅमेऱ्यासाठी आहे
ओके.
ऑन आहे तो ऑन फक्त खिशात टाका मी डायरेक्ट टाकला तरी चालेल वरती लावून घ्या. हा कॉलर
येतं?
खिशात टाकला तरी चालेल.
Okay, good afternoon, all of you. After lunch and after 1 hour after lunch and to work on the last session of this first day, this is really a crucial thing. So here we gathered about to discuss collaborative strategies of our teaching mathematics. Particularly, I am going to discuss with you about differential equation topic. Okay. So first of all, what is engineering mathematics? It's not about equations and solving equations on pages. So it is about to model, analyze, solve some practical problems or applications which are related to real life worlds. Okay. It's not about only calculations. Okay. But engineering students feel that mathematics is only for calculations. So this is not the case. So it's an invisible engine behind every decision that engineer takes. So what don't see students in mathematics classroom? They don't see satellite, rocket, electric vehicles, biomedical instruments. They only see symbols, formulas and calculations. This is the fact actually. So we also mathematics staff members, we have background of mathematics only. So we don't try to teach mathematics with some applications, real life applications, including me also. So first of all, I thank organizers for giving me this opportunity to interact with you. I have been teaching only science students, not engineering students, but I have experience of 5 years experience of teaching engineering mathematics, and organizers gave me this opportunity to make my engineering teacher alive in myself. So thank you, first of all. So what is our responsibility? Our responsibility is to explore fundamental skills which are hidden or say overlooked. The power of prediction, which we can make by using mathematics, and we give meaning before purpose, before that procedure. So I think sound is not okay. Yes, not working now. So I will try to stick to our syllabus. which is given by faculty members, how to teach differential equations. So this is our traditional syllabus. Syllabus starts with differential equations, order, degree, variable separable form, homogeneous form, then exact differential equation, then integrating factor, linear differential equation. So this is the sequence of our syllabus. If you see any book, engineering mathematics book, so sequence is like this. Is it working? नाही ॲनिमेशन जास्त आहेत त्यामुळे हेच सोयीचं जास्त राहील. So this is typical syllabus, not working actually.
प्रोसेस ना स्लो आहे त्याची थोडी,
ओके
म्हणजे हे केलं तर बॅक आणि हे केलं तर नेक्स्ट
पण ते होत नाही ना तर नेक्स्ट. And then finally, if you see our syllabus, there are so many applications. So you see any engineering syllabus, this is the common pattern. Initially some theoretical content is there, and then at the end there are so many applications. But students lose their interest in studying these theoretical concepts, okay? And then they will not study applications which they require to study. So this is about syllabus. This is about traditional way of teaching. So we act how people teaches traditionally. For example, if you have to study exact differential equation, how teachers start with? Yes, how will you teach exact differential equation? What is exact differential equation? First of all, try to clear this thing. What is exact differential equation?
We can express that term as a total derivative of something.
Yeah, but in some colleges, people start with m dx plus n dy is said to be exact. M dx plus n dy is equal to 0 is said to be exact if delta m by delta y is equal to delta n by delta x. And then do this example with this example, y square dx plus say 2xy dy is equal to 0. So this is mechanical actually, this is dry way to teach. So just give definition or necessary sufficient condition, then take one example and then compute this, what is this m, what is n, then compute delta m by delta y, and the equality is satisfied, therefore equation is exact, and then writing solution. So these are only calculations. In this calculation, some people choices another differential equation just like this, e raised to x square sin 2x tan inverse x dx plus say for example e raised to sin inverse x di equal to 0. This is not a good choice. Okay, you can check exactness of this differential equation, but it will take time. But our objective is to explain exact differential equation. Okay, so our main story is to express exact differential equation, and you are wasting your time and students' time in calculating these derivatives, partial derivatives. So that thing I want to mention here. Before teaching, your choice of example is very, very important. So which examples you are choosing to explore or to present in front of students, this is very important thing. So if you have to teach exact differential equation, select equation which is very simple to compute these derivatives. It will not take much more time in computing derivatives. That choice is very important. Otherwise, student will lose interest in learning these things. One more thing I want to share with you. When I was in my first lecture, say in Sinhagad College, I went to classroom and I started eigenvalues and eigenvectors. I considered some arbitrary matrix, 3x3 matrix, okay, and explained how to compute eigenvalues. I got cubic polynomial here. some cubic polynomial, but I couldn't find eigenvalues easily because roots of these equations are not integers, no? Not always. So we are taking examples which have integer roots. So I used to use quintic method, then that is different story to explain that method. But student thought that teacher is not appropriately teaching eigenvalues, okay? Because it is not a simple job to compute roots of cubic polynomial or cubic equation. So our focus is to teach eigenvalues. So your choice of example must be perfect and precise, okay? So if you are going to teach eigenvalues, choose matrix whose characteristic polynomial has easily eigenvalues which are either 0, 1 or 2 like that, so that you can easily guess the eigenvalues and you can explain your content. So it is important to choose the examples. Then after teaching this topic dryly, next activity we perform is that we ask students to solve 20 problems on this, okay? If you see engineering books, there is a big mistake that if you see examples, there are many examples which are focusing on only complicated calculations rather than conceptual understanding. So for example, double integration, triple integration, complicated surfaces are there. Notion is to compute or to understand double integration and triple integration, but they are wasting energy in constructing these surfaces, then constructing ranges of these integrals. So in teaching, avoid these things initially. After that, gradually you can increase the level. So this is my first suggestion I want to share with you. So traditional method is procedure driven, focusing on training students to proficient algebraic solvers. So we are making algebraic solvers. We are making engineering students as algebraic solvers. So they think only about to get 40 marks in the subject due to such type of explanation or learning or teaching learning processes. So what we taught, the solution steps. We are explaining only solution steps. First of all, check this, then check this, then check this, and then do this, like that. So what we taught, the solution steps. So in differential equation particularly, what we do, this is the differential equation which falls in this category. This differential equation which falls in this category. So we are categorizing differential equations. And then we explain methods. So majority students spend time in mastering complex integration techniques. Rigid steps I told you. So next one is sequential topic flow. So syllabus is provided to you. First unit, then second unit, or first topic, then second topic, and we go with sequential procedure. This may be the situation that if you are starting third topic, this has direct application, which I have mentioned in last chapter. Okay, so I suggest to use or to start with applications first. I think cell is cell. Thank you. So we are missing big picture here. Modeling is skipped. So initial part of our lecture should be modeling part. You just model one equation and then leave it. Then explain how to solve these equations. Once we explain methods, then ultimately come to our original model problem and then solve that problem. I think this should be the better way to encourage the students. So students know how to solve this differential equation, but they don't know why to solve this differential equation. This is very important thing, that students are not asking why we need to solve this differential equation. So ignoring reality, most of the real world problems are non-linear and cannot be solved by hand. So for that we need to use some approximation methods. Abstract answers, students don't visualize what that formula means. So we are just giving formula. For example, here delta m by delta y equal to delta n by delta x. How that formula came, we need to explain this. Okay. Missing insights. We rarely use direction fields, slope plots to show differential equation is a map of slopes. This thing is missing in differential equation. Next. Okay, next. So what are the limitations in traditional approach? So we only use chalk and talk style in teaching. So along with chalk and talk, we can use different ways of ICT, you can say. Delay in applications. So we start applications at the end of our syllabus. So you can start syllabus, begin with applications. So focus on solution, not formulation. So this is the example. So in engineering examination, you can see, solve the following differential for the current. So differential equation is directly given in terms of current. 5 di by dt plus 2i equal to 10. Means already you modeled the differential equation and you are asking only to solve this differential equation. So how that differential equation is formed, you haven't asked this question. Okay. So instead of asking such type of question, try to phrase the question so that student can model the differential equation. Then he can recognize which method we need to apply for the differential equation, and then ask about the solution, and then try to get again physical interpretation of the solution. So such type of sub questions should be in your question paper. So instead of this, if you I saw papers containing such type of questions. So no geometric insight. So graphical representation, curves, tangents, these things should be the part of teaching, beginning part of the teaching. Okay. So lack of interpretation. So we are not giving interpretation of what is derivative dy by dx means, what is double derivative means. And in the differential equation, first derivative, second derivatives are there. What does it mean? So we need to explain these things. Next. So underestimation of numerical methods. So that I discussed. Okay, next. So in traditional teaching, what happens? Student will get higher procedural proficiency but low conceptual understanding. So student become very skilled in classifying equations and executing these algebraic calculations. But next, there will be deficiency in conceptual understanding and why this solution method works and what is the importance of these methods. They will not understand. Failure in model real world problems and limited predictive and interpretative ability will not be developed among the students. So what we need to do for that? So modern way of teaching is to fixing the focus. So during teaching the differential equation, our focus should be on modeling the differential equation first, and then analyzing that differential equation, and then we discuss the methods. So every topic you begin with a story. Just like layman can understand introductory part of that the concept which you are going to start in the lecture. So every topic should be start with some story related to engineering applications. Next, focus on modeling. So from that story you will get some questions, and then from this question you can model differential equations. We will see some cases afterward. Next, use of technology. Sometimes if there are clumsy calculations, you may use computer to do these calculations so that you can directly continue your story. Okay. Next, okay, this is the syllabus which is given by our faculty members. This is our first unit, second unit, and this is third unit. These are mentioned here. But my suggestion is, unit 1 and unit 2 will be better to go in hand. Okay. So if you start formulation of differential equation, try to give some application of this, some story of this topic. Exact differential equation, make some story which will attract engineering students to learn this exact differential equations. Okay. And so on. Next. So before starting the course, you should introduce the structure of the course, first of all. Then course objectives, as sir discussed. In the first lecture, you need to introduce course objectives, syllabus, textbook, outcomes, and then give also your lecture plan. Also explain your evaluation components and evaluation processes. So these topics we can study later or discuss later on. So suppose new course is started, differential equation. So say something about differential equation part. What is the differential equation? So where it is applicable? So in differential equation, whenever there is change in the environment or anything, derivative will come in the picture, and once derivative is there, and if you have to model something, that means differential equation will be in picture. So derivative is backbone of this course actually. And that derivative is nothing but how the present creates the future. That relates with this thing. So the differential equation is an equation that involves unknown function and its derivative with respect to one or more variable. So then you can give some such type of examples. Initially you can give such type of examples to student. The next. Then say where that derivative occurs, where there are changes or change in the system or change in the status, there will be derivative. For example, in vibration in mechanics, machines, heat exchangers, there will be derivative and differential equation. So in civil engineering, structural analysis and bridge oscillations, derivative comes in picture. Okay. In electric engineering, circuits and signals. In electronics, filters and communications systems. In computer network, neural network. So there are so many examples where derivative comes. Next. So if you don't study derivative, if you underestimate differential equation, then what will be the cost of that thing, underestimation? So you should explain student, if you miss to study differential equation, what will happen? This is one example, that the $1 billion differential equation. In 1919, NASA launched the Mars climate orbiter worth rupees 125 million, and a tiny differential equation used wrong units, foot and pound system and Newton second system. That spacecraft is crashed into Mars. Why this happens? Wrong interpretation of derivatives or differential equations. So this highlights the importance of differential equation. So message is, differential equations are not just formulas, they are the precise rules of universe. Misinterpret them and you will lose mission. Next. So these are images. So this highlights the importance of differential equation. Next. So after introducing about the differential equation title, you can say little bit more about applications. One step next. So imagine that you are engineer tracking a satellite and you don't know the satellite's exact position tomorrow, but you know its current position and the rule of change. Means if you know derivative, then you can predict where that rocket will go by using the information, derivative information and direction. So you can predict where missile will go. So the differential equation is powerful and compact summary of universe rule of change. So our job is to teach our students. It's okay. So the modeling foundation from concept to code. So once we have concept, use differential equation and write mathematical form of that physical problem. So this, how the engineers create these things? It's 4-step journey. First step is about physical insight. Next. Then mathematical modeling or formulation. Next. Mathematical solution. And physical interpretation of solution. That I told you. So next step is, before starting differential equations, you must emphasize on the meaning of derivative. So derivative is change in quantity with respect to change in time. In mechanics, how to look towards that derivative, you can use that displacement and velocity and acceleration relationships. So if you know how fast temperature or velocity population is changing at every instant, so question is, can we reconstruct what the temperature or velocity or population must be over time? So answer is affirmative, that reconstruction is solving the differential equation. Next. So this is well-known story about Newton's. Newton did not ask why the apple falls, but he asked himself, how fast does its speed of it falls? And from this question, he got the derivative or differential equation dv by dt is equal to g, constant of acceleration. So that tiny equation explains rocket, missile and aircraft Mars missions. So this is new engineering area. Next. So about previous one. अजून मागे का? Okay. Imagine a car. So main object of differential equation is derivative. So you can explain the meaning of derivative by using these examples. Imagine a car is at a signal. You press the accelerator. Car moves faster and faster. Its speed changes every instant. To understand the derivative as an instantaneous rate of change, you know these explanations, velocity, acceleration, means rate of change of displacement with respect to time is velocity, and rate of change of velocity with respect to time is acceleration. So how they will feel acceleration? If there is large change in acceleration, how you feel? If there is large change in displacement, you can feel that car is moving fastly, isn't it? If there is large change in displacement with respect to time, then you can realize in your car that car is moving fastly. But if there is large change in acceleration, what you will feel? Large change in acceleration, or suppose zero change in acceleration means velocity is, means you will not feel, you are just sitting in some chair like that, isn't it? But if acceleration is increasing, how you will feel in car? And the next question is, when acceleration is changing, not velocity, acceleration is changing drastically, then how you feel in car? You will get a jerk. If there is large change in acceleration, you will get a jerk. Okay? In small interval of time, acceleration, there is large change in acceleration, and that's why you feel it as a jerk. Okay? So try to inculcate the physical significance of derivatives in students' mind. Okay? It's okay. Full केली तरी चालेल म्हणजे. So suppose this is our first topic. This is about introduction of differential equation. Now this is our first topic, order and degree of the differential equation. So you can land your teaching in this way to our first topic. Now this is our first topic, order and degree of the differential equation. So before starting our syllabus, take say big story about the differential equation, its applications, importance, significance, like that. So what is order and degree? So don't say directly that suppose this is differential equation d2x by dx square plus and so on, and then highest derivative term is this and its order is 2, therefore order is 2 and its power is 3, therefore power is degree is 3. Not like that. So tell something about order and degree, why these are important. Okay? So for example, suppose a person is infected by COVID virus and doctor wants to know whether that person will recover fully. If that doctor knows your current condition, suppose COVID virus is, a person is infected by COVID virus, and if we provide information only that she is infected, so that information is not sufficient to say about the recovery of that patient. Okay. This is very less information. That person is infected by COVID. This is not sufficient information to say about recovery of the person. But if you add some information that your condition, that I am infected by COVID virus and progress rate, and this is my progress rate of recovery, isn't it? Once we have progress rate, that means you have more information. Then you can predict that when you will recover little bit. Okay? So this is better information. Once we provide progress rate, rate means derivative here, progress rate means. But if we provide third situation, if we provide your condition, rate of progress and rate of change of that your progress. So what that signifies, rate of change of progress? Derivative of derivative, isn't it? Rate of rate, it's double derivative. Means if you have double derivative, then that from that double derivative you can interpret. Suppose rate of rate is higher. What is mean by this? Rate of rate is higher means the rate which you are recovering, that rate is higher, isn't it? Means this gives you more guarantee that you will recover. So in that sense, derivative gives more informations. Derivative gives more informations, and that's why it is very important to have more derivatives of functions. Okay? So that higher order derivative in differential equation interprets that you have more information about this y. Okay? Okay, how much information you have, that is nothing but the order of the differential equation. That I want to say you here. So in that sense, you can explain order of the differential equation, which is very simple and initial part of our syllabus. So student may take interest in derivative. Once student got interest in derivative, half part is over of our teaching. So while begin is half done, this is one popular saying. So begin with some story, some significance of your story, okay, importance of your subject. That means you completed your half job. Okay. So next topic is formulation of differential equation. Again, don't go by our traditional method, formulation. For example, y is equal to c1x plus c2x square, then y dash equal to this, y double dash equal to this, eliminate c1, eliminate c2, and we got the equation. This is the formation of differential equation. Okay, this will kill teaching, understanding skill, okay, imagination skill, mathematical modeling skill among the student. Okay, so these are simple concepts, but teach differently. So just previous one. For example, nature doesn't give equations directly. We observe the world and we describe by formulating and by modeling differential equation. So for example, these are magnetic waves, for example, isn't it? So these waves we can describe by some curves. Y is equal to x square, for example. Y is equal to 2x square. Y is equal to 3x square. So y is equal to cx square. So y is equal to cx square is the family of curves which represents these magnetic fields. But what is the law that governs the essence of all these curves? That is nothing but the differential equation. What is the common property of y is equal to x square curves, cx square curves? So these are the curves, just like that. And like that, y equal to, if c is negative, then you will get such type of curves. So all these family of curves, there is one property that all curves passing through origin. What about the curvatures of these curves? Or if we take a tangent at this, like that, you will some pattern among these, isn't it? So how to make an equation which governs the properties of all these curves? That is nothing but, see, if we take y is equal to c1x square, this is particular curve. If we take y is equal to 5x square, this is one particular curve. But I want equation which governs all these equations at a time. So what we need is to eliminate this c. Because for each c, you will get a particular member. But I want combined equation for all, which governs all these. So for that, what we need is to remove c. Try to get answer from students that we need to remove c. They will say we need to remove c. We need equation which is free from c. So how we can do that? By using derivative we can do that. Okay, let's do its derivative dy by dx equal to 2c1x, isn't it? And then get the value of c1 and then back substitute. You will get new equation which is free from c. That's the differential equation. So in this way you can initiate these differential equation topics. Okay. Next, or another way is to start the formation of differential equation topic is to give some direct application. Okay. Once students have introduced derivative concept, you can directly give some application that a dead body was discovered in a room at a stable temperature 25 degrees Celsius. A police came at the room at 10 a.m. when the temperature of the body was 32 degrees Celsius, and 1 hour later it dropped to 30 degrees Celsius. So question is that when did the victim die? Just ask student to try to model this question you should help student to model this question, because this is beginning to learn the differential equation. Okay. So how will they think? So try to write this information here. Suppose theta is the temperature of a body at a time t, for example. Now initial temperature is 25 degrees Celsius, no? Sorry. At 10 am temperature is 32 degrees Celsius. So 10 am, so when time t is equal to 10, what is the temperature? 32 degrees Celsius. And one more reading is there. After 1 hour, means after 60 seconds, 60 minutes, what is the temperature? 30 degrees Celsius. And directly question is asked that when did the victim die? One more information is given, the temperature of that room, that is 25 degrees Celsius. So from this information, can we detect murder time or time of murder or when victim die? So they will think, try to understand behavior, means from these readings, they can understand that temperature is decreasing. This is common property, normal property of a body, that temperature will decrease, fall down, and that will go to equilibrium, and that will balance to the temperature of room or surrounding. So how this curve looks, temperature curve looks. Okay. So curves are like this. As time is increasing, temperature of the body is decreasing. Okay. Time is increasing, temperature decreasing. Means rate comes in the picture. That's the Newton's law of cooling, isn't it? So the rate of change of temperature means d theta by dt. Rate of change of temperature is proportional to what? Difference between, because difference of body and room temperature is becoming negligible, isn't it? Means theta and theta naught, this difference becomes negligible. So this derivative is proportional to these things. So from that you can directly write the equation like that. But as time increases, temperature decreases. That's why we attach minus sign here, where k is positive here. Also give significance of this k. What is that significance of k? Temperature coefficient, isn't it? So once we have this differential equation and we have conditions, when t is equal to 10, theta is 32, and when t is equal to 60, theta is 30, and question is, what is the time when theta is? Yes, when theta is? I want time, or we want time of death. So what will be theta? Assume that victim was normal at the time of death. So that is 37 degrees Celsius. So this is just the initial value problem. Okay. So this is the differential equation, and these are some conditions. But yet we have no method of solving differential equations. So up to this step you can model problem like this, and then focus on how to solve such type of differential equation. It's separate story. Okay. Now this is linear differential equation, then say how this is linear, and what is the procedure to solve linear differential equations or variable separable form, that you can start by providing such type of example. So because students will realize that solution of differential equation is important for getting the time of this detection, or time detection. Okay. So instead of directly throwing differential equation and getting solutions, let them formulate the problem, okay, and then focus on the solutions and then interpretation. Okay. So this is the family of curves, depends on different surroundings, but in any surrounding the curve is similar, okay, decaying curve. See, this is the family of curves where you can see the rate is different here in each curve. Next. So even dead body follows differential equation. Okay, next. So this slide already I explained you that if you have family of curves, this is family of curves, y is equal to x square, cx square. For different values of c, you will get different curves. Okay. But how to represent name for this family instead of specifying particular c? And the best way is to form the differential equations. Okay. So initially you can start with simple examples, y is equal to c e raised to x, then lines, circles, like that. Graphical way. You can begin with some graphical examples or simple calculation examples, and then you can increase your difficulty level. Next. Next slide. Suppose this is our next topic, that exact differential equations. Imagine robot is moving heavy object. Don't directly start with m dx plus n dy equal to 0 is said to be exact differential equation if there exists a function u such that du is equal to m dx plus n dy. Don't do like this. Okay. Begin with this example. Okay. So that student will become attentive to understand what the physical situation is. So imagine robot is moving a heavy object and the potential energy U it gains depends on its position in 3D space. Suppose if we lift object here and object here, potential energy will be different, like that. Now if robot moves the object from point A to B, the change in potential energy is what matters. Crucially, that change in potential energy is independent of path that robot takes, where there is a conservative field. Okay. That if your field is conservative, then that potential energy is independent of path. That means du becomes 0. But du means total derivative. Dou by dou x. Dou by dou x gives the slope and dx gives the direction. Okay. Incremental direction. And u by dou x gives you derivative, rate, sorry. Okay. Slope means rate. So at which rate you are moving to dx direction, plus at which rate you are moving towards y direction, small incremental direction, that's nothing but the sum dou by dou x plus dou by dou y, and this is du equal to m dx plus n dy. So that field we can check whether it is conservative or not by using this condition. The field is conservative if there is just such type of scalar potential whose du is nothing but m dx plus n dy. Okay. Next. So here the goal is reverse process. Differential equation is given to you and we have to find that scalar potential. So initially ask student to find scalar potential by providing simple examples. For example, y square dx plus 2xy dy is equal to 0. This is your m, this is your n. So try to or ask our students to get the function u such that du becomes m dx plus n dy. Okay. So intuitively they will find. Don't tell the method directly, let them think on finding du. Okay. So in that thinking process, student will understand the relation between that du, okay, and the coefficients m and n. Okay. If we throw the method, then they will forget about the relation between partial derivatives and total derivative, isn't it? Relationship. Okay. Next. So just from this story, student can understand the importance of the derivative terms and exactness of the differential equation. Then simple examples you can ask. Okay. Next. So for example, du is mdx plus ndy, then how that dabba m by dabba y becomes dabba n by dabba x if field is conservative. Okay. That outline you can give to students. Okay. So finding u is equivalent to, or just by checking whether there existence of u is equivalent to checking equality of partial derivatives, that you can convince by proving that these two things are equal. Next. Then solve many examples, then introduce direct formula. Okay. One more thing I want to mention here in exactness, what teacher do in class, that integral first thing with respect to x and keep y constant, and second integrate with respect to x and take term free from x and y. So why this is? Try to say something about this, why this is, or directly give this problem to them, and that equivalent condition is dabba m by dabba y is equal to dabba n by dabba x. So we have this information, and we want u such that du becomes this thing. So we have only these three things. We have mdx plus ndy equal to 0. We know this equality. Okay. And we want u such that du becomes this thing. Okay. Then student will think that suppose u is equal to some function, some say phi of x comma y. Okay. Then he will do du for that. Then he will take one as a m, second as a n. Then he will compare with this m and n. Once you have m and n, then he will take derivative with respect to y, derivative with respect to x, equate them. Okay. There are examples like that. Instead of giving direct formula, let them work on finding u. Okay. Next. So this topic has core applications in work done also, because work done is nothing but force into displacement. Suppose F is F1 dx plus, suppose force is mi plus nj, and direction is dxi plus dyj, then work done is force into displacement dot product. So this gives you m dx plus n dy. So when field is conservative, that work done is negative of that potential energy. So you will get dw is equal to minus du in this case, and means derivative of w is nothing but derivative of u. But du is 0, that means you will get the family of solution as a u of xy equal to constant. Okay. So such type of applications if we introduce initially, then student may take interest in learning this exactness of the differential equation. Okay, pude equations reducible to exact form. If field is not conservative, so relate this conservativeness with exactness. Okay. If differential equation is not exact, means field is not conservative. So if field is not conservative, how to make it as a conservative like that? So we need to multiply by some factor so that it will become conservative. So explain this with some physical example or model. Next one. So this is the example here. Change in heat transfer is suppose dq. In the direction of x axis there is m dx change, and in the direction of y n dy पाहिजे, there is change in y axis is n dy, and if it is not exact differential equation due to isothermal processes or any adiabatic processes, मेकॅनिकलमध्ये तुम्ही पाहिलेले असतील या प्रोसेसेस हीट ट्रान्सफरच्या बाबतीत, त्याही थोड्या समजून घ्यायला लागतील तुम्हाला. म्हणजे इंजिनिअरिंग मॅथमॅटिक्स शिकवताना नुसतं मॅथमॅटिक्स शिकवायचं नाही आहे. आपण मॅथमॅटिक्स टीचर असल्यामुळे आपल्याला डायरेक्ट फक्त मॅथमॅटिक्स शिकवायचं असं सवय लागून गेलेली आहे. आपण इंजिनिअरिंगला शिकवतो आहे, हे वेगळेपण आहे आपल्यामध्ये. ते वेगळेपण असल्यामुळे इंजिनिअरिंगच्या काही नोशन्स आपण समजून घेणं फार गरजेचं आहे, आणि त्या नोशन्सच्या पॉईंट ऑफ व्ह्यू आपल्याला मॅथमॅटिक्स कसं रिलेट करता येईल ते करायचा आपण प्रयत्न केला पाहिजे. आपण एक्सपर्ट नाही आहे त्यातले, आपण विचारले पाहिजे, ती एक्सपर्टी आपण हळूहळू इम्प्रूव्ह केली पाहिजे. मीही शिकतोयच, मी याच्यातला एक्सपर्ट नाही आहे, पण आय एम ट्राईंग टू रिलेट दिस थिंग्स विथ मॅथमॅटिक्स. हां,
सेकंड इयर पर्यंत ना, सेकंड इयरच्या इंजिनिअरिंग पर्यंत ना, खरं 11वी 12वीच्या पुढचं मार्क्स लागत नाही, तेच रिपीट होत असतं
बरोबर.
मेकॅनिकलमध्ये. तर 12वी पर्यंत हे झालेलं असतं, त्यामुळे मॅथमॅटिक्सच्या टीचरना ना फार कष्ट घ्यायची गरज नाही. ते सिंपल न्यूटन्स लॉ ऑफ कूलिंग, आता त्या डेड बॉडीच्या बद्दल किंवा हे आता एंट्रोपीचं 12th आलेलं असेल, थोडंसं फक्त
येस बरोबर.
सो इट्स नॉट व्हेरी डिफिकल्ट. आणि मला असं वाटलं की खरं एक चांगलं काय करायला पाहिजे, ॲज अ ग्रुप ॲक्टिव्हिटी होऊ शकेल की असे छोटे छोटे एक्झाम्पल्स
तयार केले पाहिजेत. मला हेच आता ॲक्टिव्हिटी द्यायची होती. हां, मगाशी आपलं डिस्कशन झालं सर की मी आता एक 2-3 दिवस तयारी करत होतो प्रिपरेशनची, त्यावेळेसचा माझा एक्सपिरियन्स मी सांगतो. सरांनी सेम, म्हणजे त्यांनी आत्ता इथं बसल्याबरोबर त्यांना तो सुचला आहे, मला त्याला एक आठवडा लागला इथं समजून घ्यायला. तर हे मॅथमॅटिक्स ना कनेक्ट करण्याची फार गरज आहे सध्या. तुम्ही ज्या मेथड शिकतायत त्याला थोडासा रिलेव्हन्स द्या. थोडासा रिलेव्हन्स दिला तर इंजिनिअरिंगच्या लोकांना तो आवडेल, स्टुडंट्सला. कारण ते इंजिनिअरिंगला ॲडमिशन घेत आहेत, त्यांना फिजिकल प्रॉब्लेम्स समजून घ्यायचे, जे काय आहेत फिजिकल इंटरप्रिटेशन, मॉडेलिंगचे प्रॉब्लेम्स. तुम्ही कॅल्क्युलेशनमध्ये त्यांना इंटरेस्ट नाही आहे, पण त्यांच्या एरियातलं जर तुम्ही, जसं सर सकाळी म्हणाले, त्यांच्या एरियातलं जर एक्झाम्पल तुम्ही रिलेट करू शकलात तर ते असे एकदम अटेंटिव्ह होतील तुमच्या क्लासेसमध्ये. तुम्ही हा प्रयोग करून बघा, तुम्ही वेगळं घ्या डायरेक्ट असं काहीतरी ॲप्लिकेशन, मुलं असं सावरून बसतात लगेच. म्हणजे तो एक भाग मला सांगायचा आहे. त्यासाठी तुम्हाला काय करायला लागेल, हा जो वर्कशॉप जो आहे ॲक्च्युली असं डिझाईन करायला हवं होतं अजून पण, की हे 3 टॉपिक आहेत, ह्या 3 टॉपिकचं कसं बिगिनिंग करायचं. त्यासाठी तुम्ही 4 एक्झाम्पल, तुम्ही 2 एक्झाम्पल घेऊन या. त्यातलं लवकर पटणारं एक्झाम्पल कोणतं आहे, मुलांना पटणारं ते एक्झाम्पल सुरुवातीला घ्या, त्याचा सिक्वेन्स लावा आणि तो रिलेट करा आपल्या टॉपिकशी. मग मुलांना इंटरेस्ट येईल. किंवा तुमची ब्रँचनुसार ते प्रॉब्लेम्स आपण चॉईसिंग करा. तसं जर चॉईस करू शकलो आपण तर मुलांना ते इंटरेस्टिंग वाटेल. इवन पुस्तकात सुद्धा जे काय आता पुस्तकं आहेत मार्केटमध्ये, भरभर डिफरन्शियल इक्वेशनच्या मेथड लिहितात आणि भरभर ॲप्लिकेशन सांगतात. खूप दरी आहे. इवन चॅप्टरच तोडलेला त्यांनी, दरीच तयार केलेली दोन्ही चॅप्टरमध्ये. तर माझं असं म्हणणं आहे की बिगिनिंग थोडंसं फिजिकल इंटरप्रिटेशनची पाहिजे, मग मॅथमॅटिक्सची स्टोरी येईल, सोल्युशन्स येतील, आणि मग पुन्हा ओरिजिनल प्रॉब्लेमकडे जायचं. जसं आता इथं न्यूटन्स लॉ ऑफ कूलिंग तिथं सोडून दिला प्रॉब्लेम. पुढे जाऊन मग ज्या वेळेस तो चॅप्टर आपण शिकवायला घेऊ त्यावेळेस तो पुन्हा कॉल बॅक करायचं की आपण असा प्रॉब्लेम मॉडेल केलेला होता, आता आपल्याला तो सोडवायचा आहे. तर अशा पद्धतीने प्रत्येक टॉपिकसाठी स्टिक टू द सिलेबस. मी सुरुवातीला सांगितलं की सिलेबसवरती स्टिक राहून त्याच्यावर वर्कआउट करणं फार गरजेचं आहे. की हा टॉपिक आहे, मग तो किती सिम्पल टॉपिक असू देत, ऑर्डर डिग्री असू देत, नाही तर फॉर्मेशन असू देत, नाही तर लिनियर डिफरन्शियल इक्वेशन असू देत, तो टॉपिक पकडून तुमच्याकडे खूप मोठी टीम आहे खरं तर. म्हणजे मला खूप आनंद होतोय की एवढी मोठी टीम ह्याच कॉलेजची ना.
ते तुमचा जो प्रॉब्लेम होता ना याचा फर्स्ट,
हां,
तर तुम्ही ब्रांच वाईज सगळे प्रॉब्लेम्स ते एरियाज दाखवले, लिनियर इलेक्ट्रिकल सर्किट्स वगैरे. मला 2 गोष्टी इथे असं वाटतं की आता जेव्हा तुम्ही लिहिलं डी थिटा बाय डी टी इज इक्वल टू -k इंटू ब्रॅकेट थिटा मायनस थिटा, आणि मग तुम्ही आधी गिवन कंडिशन्स दिल्या टी इज इक्वल. सो मुलांना ना इथपर्यंत कळतं की समथिंग विच इज रिलेटेड टू चेंज इन टेम्परेचर विथ रिस्पेक्ट टू टाइम.
बरोबर.
पण जे ब्रॅकेटमध्ये थीटा मायनस थीटा 0 हे जे आहे हे नॅचरल याच्यातून आलंय.
हां बरोबर.
जो भाग आहे ना हा त्यांना पहिल्यांदा टीचर घेतलेलं एक्झाम्पल खूप सोपं वाटतं, ते तिथे जमतं, पण प्रॉब्लेम जर थोडा डिफर झाला तर ते जे बिहेवियरचा जो भाग
बिहेवियरल तोच माझा प्रश्न आहे की हे एक्सप्लेन करायला पाहिजे. आता हां कसं आलं. येस
तसेच एक्झाम्पल झाले पहिले 2 लेक्चर्स घेतले पाहिजे. नॉट इव्हन RLC सर्किट
काहीच नाही
RLC सर्किटचे का नको मला असं वाटतं, कारण टीचर घेताना एक R आणि एक L असं घेतो di/dt किंवा एक R एक C घेतो, पण एक RLC असं आलं किंवा पॅरलल कॉम्बिनेशन आलं की मुलं गडबडतात. टीचर LCचं एक्सप्लेनेशन देत नाहीत आणि मुलांना ते मॅथ्समध्ये तिथे
हा पॉईंट महत्त्वाचा आहे. RLC डायरेक्ट घेण्यापेक्षा आय रेकमेंड टू यूज LC. हां LC एक 2 मिनटं. LC सर्किट जर घेतलं आपण त्या केसमध्ये तर त्याचं मॉडेलिंग ॲनालॉगस आपल्याला पाहता येतं. वॉटर फ्लो जसा आहे, जसा करंट फ्लो होतो तुमच्या सर्किटमधून, त्याचं ॲनालॉजी तुम्ही वॉटर फ्लो अशी करू शकता. रेजिस्टन्स म्हणजे तिथलं ट्रॅफिक सिग्नल वगैरे किंवा काय जे असेल.
मुलांचं ना बेसिक इंडक्टन्स आणि कॅपॅसिटन्स हेच अंडरस्टँडिंग खूप कमी असतं.
तेच मी पुढच्या एका स्लाईडमध्ये मी ते मांडण्याचा प्रयत्न केलेला आहे की समजा कार तुमच्या ट्रॅफिक नाशिक सिटीमध्ये फिरतायत, म्हणजे एक करंट फ्लो होतो असं म्हणायचं. कार म्हणजे तो चार्ज आहे कार, आणि तो तुमच्या रोडवरून म्हणजे वायरवरून तो फिरतोय. आणि रेजिस्टन्स म्हणजे तुम्हाला लागलेले सिग्नल्स, ते सिग्नल्स तुमचे रेजिस्टन्ससारखे आहेत. जेवढे सिग्नल्स तेवढा तुमचा स्पीड कमी होणार, करंट फ्लो कमी होणार, कमी रेटने गाड्या पुढे जाणार. कपॅसिटर म्हणजे काय ह्या पिक्चरमध्ये, तर कपॅसिटर म्हणजे एक अशी पार्किंग एरिया आहे असं समजा. पार्किंग एरिया की जिथं त्या करंट जातो, स्टोअर होतो थोडा काळ, पार्किंग एरिया आहे. त्या जर कपॅसिटरमध्ये गेला तर काही कार इकडच्या पण कमी होतात, व्होल्टेज तिथे पण त्याचा बॅलन्स कसा होतो तुम्ही सांगू शकता. तर त्याची ॲनॉलॉजी तुम्हाला अशी पण सांगता येऊ शकते कार्सच्या बाबतीत किंवा वॉटर फ्लो जो आहे पाईपच्या नेटवर्कमधून, तसाही तुम्हाला सांगता येऊ शकतो. म्हणजे करंटचं फिलिंग आलं पाहिजे, चार्ज पास होतोय, त्यांना कुणीतरी अडवतं आहे, रेजिस्टन्स म्हणजे काय होतं आहे ते कळलं पाहिजे. आणि कपॅसिटर नेमकं त्याचा काय रोल आहे तिथे, तो करंट स्टोअर करतोय आणि मग त्याला गरज वाटेल त्यावेळेस तो करंट ज्यावेळेस कमी असेल, रोडवरती कारच कमी असतील त्यावेळेस तो करंट बाहेर येतो तिथे. जसं कार त्या रोड पार्किंगमधून बाहेर येतात, गर्दी नाही आहे मग करंट बाहेर येतो. म्हणजे करंट कमी व्हायला लागला म्हणून तो साठलेला करंट जो आहे कपॅसिटरमधला तो कंडक्टरमध्ये येतो. ही जी ॲनॉलॉजी आहे ती समजणं फार गरजेचं आहे. त्यासाठी तुम्हाला आपलं पण जे माइंडसेट आहे थोडासा इंजिनिअरिंग करून घ्यायला एक संधी आहे मी तर म्हणतो.
तर मी एक सिक्रेट रिव्हील करतो की 12वीच्या पुढचं काही फार भव्य दिव्य इंजिनिअरिंगमध्ये नसतं. मला वाटत असतं की फार काहीतरी ग्रेट अजिबात. त्यामुळे 12वीच्या कॉन्सेप्टवरच तुम्ही केलं ना तेवढं
येस सर.
नसतं. शाळे सर बरोबर आहे काय मी म्हणतो ते?
बऱ्यापैकी बरोबर.
बऱ्या म्हणजे खूप नाही आहे. मला जे आठवतं मेकॅनिकल बेसिक हेच आहे. तुम्ही
बेसिकच आहे.
ते जर नीट केलं असेल ना तर म्हणजे मला म्हणायचं की मॅथमॅटिक्सचे टीचर हे सहज करू शकतात.
सहज सर, मॅथमॅटिक्सचा टीचर काहीही करू शकतो, हे माझं स्टेटमेंट आहे. काहीही करू शकतो मी तर म्हणतो, काहीही म्हणतोय मी, फक्त मनावर घेतलं पाहिजे.
डिस्कशन मधनं 2-3 गोष्टी मला म्हणजे जस्टिफाय करायच्या आहेत.
हां.
पहिली गोष्ट म्हणजे मॅडमचं जे म्हणणं होतं की थीटा मायनस थीटा नॉट इथपर्यंत मुलांना आणायचं आहे. तर हा कुलिंग लॉ शिकवताना आहे ना, हा कुलिंग लॉ न्यूटन्सने बाय
ऑब्झर्वेशन तेच
बाय ऑब्झर्वेशन लिहिलंय.
बरोबर.
जस्ट ऑब्झर्वेशन. मग तो ऑब्झर्वेशन म्हणजे काय, मग ते स्टेटमेंट येईल रेट ऑफ चेंज इज प्रपोर्शनल टू टेम्परेचर डिफरन्स. मग तेवढं मुलांना नाही माहित असतं. मग डिफरन्स बिटवीन काय, सराउंडिंग अँड द टेम्परेचर ऑफ बॉडी. मग सराउंडिंगला एक व्हेरिएबल म्हणा, याला दुसरा व्हेरिएबल म्हणा. मग डिफरन्स म्हणजे काय, सबस्ट्रॅक्शन.
बरोबर आहे.
मग मुलांना आम्ही आणतो तिथपर्यंत की डिफरन्स आहे हा प्रपोर्शनल. मग डिफरन्स म्हणजे कोणाला, मग थीटा मायनस थीटा.
जी सिच्युएशन म्हणजे जो स्टेटमेंट होता ना, त्या स्टेटमेंटमध्ये म्हणजे कधी कधी असं की आय हॅव टू रिलेट दिस टू ड्रॉप इन टेम्परेचर ओव्हर टाईम. हा भागच कधी कधी काही मुलांना नाही कळत.
मग तिथे तुम्हाला काय करायला लागेल, तिथे तुम्हाला काही 1-2 ऑब्झर्वेशन, एखादी चहाचा कप, थर्मामीटर, रिडिंग घ्यायला लावणे,
किंवा असे
असं काही प्रयोग करता येऊ शकतात.
आणि not just theta
Examples.
one, theta zero. असं काही वेगळं एक्झाम्पल आहे का की जिथे वेगळं रिलेशन आहे दॅट कम्स नॅचरली फ्रॉम सच प्रॉब्लेम स्टेटमेंट, असे वेगवेगळे असं मला म्हणायचं.
आता इथे आपण फार डिटेल का नाही केलं, कारण आपल्याला पुढचे टॉपिक घ्यायचे. पण मी ते सांगितलं की हे एक्सप्लेन केलं गेलं पाहिजे की हे कसं एक्सप्लेन करायचं. तर तुम्ही ॲक्च्युअल एखादं तुम्ही थर्मामीटर आणि चहाचा कप आणून त्याचं कुलिंग कसं होतं त्याचे काही रिडिंग जर घेतले तर त्याला एक पॅटर्न दिसेल. तुम्ही अजून थोडं थंड जागेत घ्या, आता तुम्ही थंड जागेत घ्या, थंड जागेमध्ये वेगळा पॅटर्न दिसेल, कर तशाच टाईपचा, पण त्याचं जे बिहेवियर आहे ना ते बिहेवियर मात्र जे काय आहे काय लोगॅरिथमिक ते तसं तुम्हाला तिथं दिसेल. अजून तुम्ही AC गेलात, तुमचे पहिले रिडिंग तिकडे जे होते 5व्या सेकंदाला समजा टेम्परेचर 30 डिग्री होतं, तर AC गेल्यानंतर ते टेम्परेचर कदाचित 30च्या ऐवजी 20 आलेलं दिसेल 5च सेकंदामध्ये. फास्ट रॅपिड होईल, कारण तिथे फरक त्या ACचा इफेक्ट आहे. तो ACचा इफेक्ट, तुमच्या उन्हातला इफेक्ट आणि अजून कुठला तरी इफेक्ट वेगळ्या ठिकाणचा नॉर्मल टेम्परेचरचा, ते इफेक्ट हा इथे कोएफिशियंट जो आहे K, याचं त्याचं कनेक्शन कसं आहे हे तुम्हाला एक्सप्लेन करता येऊ शकतं. आणि हे डिफरन्स का, तर हा डिफरन्स कमी कमी होत जातोय. थीटा आणि थीटा जवळजवळ येत आहेत खरं तर. जसं जसं टेम्परेचर पुढे जाईल, टाईम पुढे जाईल तसं त्यांच्यातला डिफरन्स बॉडीतला आणि इन्व्हायरमेंटमधला डिफरन्स टेम्परेचरचा तो 0 होतोय. म्हणून तो डिफरन्स आपल्याला तिथे घ्यायचा आहे. तिथे डिफरन्स ही प्रपोर्शनल आहे ती गोष्ट. डिफरन्स जर 0 झाला दॅट मीन्स देर इज नो चेंज, तिथे नंतर चेंजच होणार नाही. ओके, चेंज, देर इज अ चेंज, देअर फॉर देर इज अ डेरिव्हेटिव्ह. हु इज चेंजिंग? टेम्परेचर इज चेंजिंग. With respect to home is changing, with respect to time is changing. So is there any other parameter right now? No. So theta is there, t is there. Theta is changing with respect to t. That means there is some rate. That rate is d theta by dt. Okay, once you know theta, but what is that rate? We don't know exactly the number, but you know that number is proportional to what? Difference between these two. By taking some initial conditions or initial readings, you can determine that temperature coefficients too. म्हणजे तुम्ही एक्सरसाइज अशाही देऊ शकता की आता हे क्लायमेट आहे, याचा टेम्परेचर कोएफिशियंट कम्प्यूट करा. काय नाही, काय करायचं म्हणजे हे इक्वेशन घ्यायचं आहे आणि तुम्हाला 2 रिडिंग घ्यायचे आहेत. त्या 2 रिडिंगवरून तुम्हाला Kची व्हॅल्यू मिळणार आहे, टेम्परेचर कोएफिशियंट. हेच तर टूल आहे, हेच तुमच्या ह्या मशीन्समध्ये वापरलेला असतो टेम्परेचर कोएफिशियंट कम्प्यूट करण्यासाठी. तर याचे कनेक्शन ॲप्लिकेशन्समध्ये कसे जातात, प्रोग्रामिंगमध्ये कसे जातात, हे फार महत्त्वाचं आहे. पुढचा जो भविष्य आहे, जसं आत्ता सकाळी स्टॅटिस्टिक्स इन्फॉर्मेशन, आत्ताचं AI स्टॅटिस्टिक्स बेस्ड आहे, पण स्टॅटिस्टिक्सला डेटा तयार करून द्यायला कॅल्क्युलस, डिफरन्शियल इक्वेशन ह्या गोष्टी उपयोगी पडणार आहेत भविष्यात. अजून रोडवरती रोबोट फिरत नाही आहेत. कारण का? कारण आत्ता स्टॅटिस्टिक्समध्ये तो डेटा नाही आहे चेंजवाला, असा रेट ऑफ चेंज, ते मोशन अवघड आहे, थोडं कॉम्प्लिकेटेड आहे. काही ठिकाणी असतील रोबोट, पण ह्याचं इम्प्लिमेंटेशन जेव्हा होईल त्यावेळेस तुम्हाला रोबोट इथं शिकवताना दिसेल. तोच रोबोट शेतामध्ये तुम्हाला दारे धरण्यासाठी दिसेल, असं पॉसिबल आहे. पण ते जे मॅथमॅटिकल फॉर्म्युलेशन जे आहे त्यासाठी ह्या ज्या अमूर्त संकल्पना आहेत गणितामधल्या त्या समजून घेणं फार गरजेचं आहे. त्याचं कनेक्शन ॲप्लिकेशनशी कसं आहे ते समजणं फार गरजेचं आहे. आता कम्प्युटर बेस्ड डेव्हलपमेंट झालेली आहे. तुम्ही डेटा द्या, कम्प्युटर काही मिनटात तो ॲनालाइज करून देतो. भविष्यात स्टॅटिस्टिक्सच्या बऱ्याचशा गोष्टी कम्प्युटर त्याच्या मनाने तो करणार आहे. त्याच्या मनानेच तो कोणतं टेस्ट डिसाईड करायचे तोच ठरवतो आहे. गरज आपल्याला ही आहे की कॅल्क्युलस म्हणा किंवा मॅथमॅटिक्सचे बाकीच्या जे ब्रँचेस आहेत त्यांचा वापर मोस्टली कॅल्क्युलसचाच, इंजिनिअरिंगमध्ये मोस्टली कॅल्क्युलस वापरलं जातं, त्याचा वापर होणं फार गरजेचं आहे असं मला तरी वाटतं. म्हणजे पण असं एक वर्कशॉप घेतला सरांनी, माझ्यातला इंजिनिअरिंग टीचर जागा केला आणि
पुढच्या वर्कशॉप
जिवंत ठेवला तो टीचर, लिटरली असा मरायला लागला होता हळूहळू तो.
मॅडम ती L, R आणि C तिन्ही इन्व्हॉल्व केले ना सेकंड ऑर्डर होऊन जातो. म्हणजे आपण फर्स्ट ऑर्डर शिकतो ना, मग सेकंड ऑर्डर आपण M3 मध्ये इन्क्लूड केलं.
ठीक आहे, म्हणजे मला असं वाटलं की
तो आपण सेकंड इयर मध्ये इन्क्लूड केलेला आहे. कारण इथे फर्स्ट इयर मध्ये आपण फर्स्ट ऑर्डरशी डील करतो म्हणून दोनच कॉम्पोनंट
सिस्टम ऑफ डिफरन्शियल इक्वेशन नाही का सिलेबस?
नाही, एकतर एल आर सर्किट फर्स्ट ऑर्डर फर्स्ट डिग्री आहे,
फक्त फर्स्ट
म्हणजे सिस्टम ऑफ डिफरन्शियल इक्वेशन असेल देन यू कॅन टेक RLC.
किंवा नुसता रेजिस्टन्स आणि इलेक्ट्रोमोटिव्ह फोर्स तुमची बॅटरी असेल तरी फर्स्ट ऑर्डर डिफरन्शियल इक्वेशन तयार होतं. पण L, R आणि C जर असेल तर मात्र ते थर्ड ऑर्डर क्यूमध्ये होईल. ते चार्जमध्ये, चार्ज त्याचा डिपेंडंट व्हेरिएबल असेल विथ रिस्पेक्ट टू टाईम.
यात एक थोडं एकच पुढचं होतं. एक सरांनी सकाळी जे लेक्चर झालं त्यातलं एक मुद्दा झाला की पहिले तुम्ही क्लासिक एक्झाम्पल्स घ्या आणि मग ते डोमेन स्पेसिफिक एक्झाम्पल. त्याच्या मागे मला वाटतं एक माझं आकलन असेल की जेव्हा आता हे आपण शिकवलं होतं तेव्हा दोन विषय एकत्र होते. म्हणजे आपण गणित शिकवतो त्याच वेळेला फिजिक्स पण शिकतो.
बरोबर.
आणि हे दोन कन्सेप्ट एकाच वेळेला मग आता शिकून इंटररिलेट करणं, इंटररिलेशन हा पुढचा वर्ग आहे. तर पहिले दोन्ही नीट समजावं लागतं. आता याच्यात काय होतं, मॅथमॅटिक्स टीचर पण तसं म्हटलं तर फारच ताण आहे की त्याला हे शिकवायचं ते शिकवायचं. बरं मुलांना हे तरी कळलं आहे की नाही हे माहीत नाही. शिकवतोय मॅथमॅटिक्स, त्याला फिजिक्स येते का माहीत नाही, त्याला हे येते का केमिस्ट्री हे माहीत नाही. मग त्याचं सगळं ओझंच आहे. म्हणजे मी टीचरचे
हां, नाही याच्यामध्ये हा चॅलेंज आहे हा. पण हा चॅलेंज तुम्ही असं त्याला स्वतंत्र जर पाहिलं ना, तुम्ही नुसतं मॅथ्स शिकवलं तर मुलं इतके ड्राय वाटतं त्यांना ते मॅथमॅटिक्स की तुमच्या ॲप्लिकेशनचं ऐकून घेण्याची ताकद पण त्यांच्यात राहत नाही नंतरच्या केसला. तर तुम्हाला ही जी सांगड आहे ना, ही सांगड अशी घालायची आहे का अशी ठेवायची आहे, अशी सांगड होणार नाही कधीच. अशीच सांगड होऊ शकते. तुम्हाला मग कोणता टॉपिक म्हणजे डेरिव्हेटिव्ह इंट्रोड्यूस केला तर मग डेरिव्हेटिव्ह पुरतंच काहीतरी ॲप्लिकेशन सांगायला लागेल. ऑर्डर डिग्री सांगितलं की त्याच्या पुरतंच ती नोशन पुढची आली पाहिजे ॲप्लिकेटिव्ह. एक्झॅक्ट डिफरन्शियल इक्वेशन सांगायचं असेल तर तुम्हाला पार्शियल डेरिव्हेटिव्हबद्दल थोडंसं त्याला अगोदर त्याला ज्ञान द्यायला लागेल. असं करून म्हणजे चॅलेंज आहे, त्याला बसून त्याचं वर्कआउट करायला लागेल, डिझाईन करायला लागेल ते व्यवस्थित की नेमकं कोणतं एक्झाम्पल कोणत्या टायमाला घ्यायचं, त्याला पण महत्त्व आहे. आणि हे चॅलेंज कुणी करत नाही आहे पुस्तकात. तुम्ही पहा ते सर्व पुस्तके आत्ता मार्केटमधले पुणे युनिव्हर्सिटीचे सर्वच पुस्तकं कंपार्टमेंट आहेत. युनिट म्हणजे कंपार्टमेंट आहेत आणि मुलं मग ते ऑप्शनलला टाकतात. असा हा प्रकार होतो.
अजून एक चॅलेंज आहे सर, म्हणजे आता हे झालंय फिजिक्स आणि मॅथमॅटिक्स हे दोन विषय तर आलेच. तर तिसरं चॅलेंज एक असं आहे की ज्याला आपण शाळेमध्ये आम्ही मराठी माध्यमात ठेवलं आपण 8 क्वेश्चन्स म्हणायचे. 10वीला गणितामध्ये HOT 8 क्वेश्चन्स. आणि ते 8 क्वेश्चन दोनच विचारायचे असतात, 5 आणि 5 मार्क. आणि ते शेवटी काहीतरी मला वाटतं 20 का 30 असे दिलेले होते पुस्तकात. त्याच्यापैकीच ते येणार होते, हे अगदी निश्चित आहे सर. पण तरीही ते हार्ड क्वेश्चन मुलांना येत नाही. याच्या मागचं एक प्रमुख कारण असं आहे, ते फिजिक्स आणि केमिस्ट्रीमध्ये नाही, ते भाषेमध्ये. म्हणजे हे शाब्दिक उदाहरण सोडवण्याची जी क्षमता आहे ती अत्यंत कमी. तेच तुम्ही त्यांना फॉर्म्युलेटेड त्या लँग्वेजमध्ये उदाहरण दिलं ना तर त्यांना सोडवलं. एक तुम्ही त्यांना शब्दात लिहा म्हटलं ठीक आहे, म्हणजे किंवा शब्दात लिहिलेलं सोडवा म्हटलं की त्यांना ते मांडता येत.
सरांच्या बोलण्यावरून मला एक असा मी प्रयोग आठवतो माझ्या मुलावरती केलेला किंवा आमच्या MSCच्या मुलांवरती. इनफॅक्ट GCDचं एक्झाम्पल द्या असं म्हटलं मी, एक रिअल लाईफ ॲप्लिकेशन द्या एखादं की इथं GCD वापरला जातो. मुलांना 15-20 मिनटं काहीच सांगता नाही आलं, GCDचं ॲप्लिकेशनच नाही सांगता आलं. GCD काढता येतो, नंबर दिले, फॅक्टर केले, कॉमन काढले, झाला GCD झालं. हे काय असं काहीतरी फेकाफेकी असे वाटते, कॉमन काढून फेकणे. ॲप्लिकेशन काय, ते कॉमन फॅक्टर काढण्याचा ग्रेटेस्ट कॉमन डिव्हायजरचा तसा लगेच संबंध नाही आहे. GCD पण कसा शिकवावा सर, हायस्कूलमध्ये सुद्धा टीचिंग कसं व्हायला पाहिजे याच्यावरती खरं त्या लोकांनी विचार करायला पाहिजे.
सर CBSE मध्ये हे फॉलो होतं बरं का सर. CBSE फॉलो ऑल दिस थिंग्स. ते ॲप्लिकेशन विचारतं. CBSEचा एक सेक्शन असा असतो की जिथे यू कांट प्रेडिक्ट दी क्वेश्चन्स. कुठूनही तो क्वेश्चन येईल, असेल एकदम सिम्पल पण तो ॲप्लिकेशन बेस्डच असेल, सिक्वेन्सचा असेल,
बरोबर,
ॲप्लिकेशन बेस्ड असेल. CBSE फॉलोज दिस.
हा प्रयोग
सर हे पण CBSE
माझ्या मुलावरती मॅडम हा प्रयोग केला मी. म्हणजे मी त्याला शिकवत होतो, पण मध्येच सुट्ट्यांमध्ये माझ्या एका रिलेटिव्हने त्याला GCD शिकवला. तो GCD शिकवला कसा, नंबर घे, फॅक्टर काढ, दुसरा नंबर घे, फॅक्टर काढ, कॉमन घे, हे GCD फॅक्ट संपला. पण त्याने त्याचं ते त्याच्यात जो इसेन्स आहे GCDमध्ये, ग्रेटेस्टनेसचा जो इसेन्स आहे तो त्याच्यामध्ये आला नाही. तो मला सारखं विचारायचं, ग्रेटेस्ट म्हणजे काय आणि कॉमन काढता त्याचं काय संबंध आहे कसा ना म्हणजे. पण मला तसं शिकवायचं नव्हतं. मला अगोदर डिव्हायझर्स शिकवायचे होते. 2 नंबर्स देणार, त्याचे डिव्हायझर्स काढायला लावणार. मग 2 नंबर देणार, त्याचे कॉमन कोण आहेत ते काढायला लावणार. मग त्यातला ग्रेटेस्ट कोण आहे तो काढायला लावायचा. मग त्यांनीच नाव दिलं त्या नंबरला ॲक्च्युली, ग्रेटेस्ट कॉमन डिव्हायझर. मी त्याला म्हटलं काही दिवस विसर, मी तुला 1-2 महिन्याने शिकविल. तो विसरून गेला ती मागची फॅक्टरवाली मेथड. 2 महिन्याने मग मी त्याला GCD शिकवलं. पण मी नुसता GCD शिकवला सर, त्याच्या पुढच्या 2 महिन्याने शेतामध्ये ज्यावेळेस मी काम करत होतो त्यावेळेस तो माझ्यासोबत होता. त्याच्यासमोर मी 2 काड्या म्हणल्या, एक 18 लांबीची आणि एक काहीतरी 12 लांबीची. त्याला सांगितलं मी की हा दोन्ही काड्यांसाठी काय करायचं, आपलं मोठ्यात मोठी काडी करायची, ब्रेक करायचा दोन्ही काड्या, स्टिक्स मोठ्यात मोठी साईज पाहिजे, ओके, आणि तुकडा एक पण उरला नाही पाहिजे. अशा किती काड्या होऊ शकतात. मी त्याला GCD असं मग काहीच बोललो नाही मी त्याला. 2 महिन्यानंतर तो विसरला होता, म्हणजे GCDचं ॲप्लिकेशन काय, ॲप्लिकेशन पण घेतलं नव्हतं मी त्यावेळेस. पण त्याने एक्सपेरिमेंटेशन केले. मी त्याला विचारलं कसं सुचलं तुला, तर तो म्हटला मी अगोदर 1 सेंटीमीटरचा होतं आहे का, तर होतात 1 सेंटीमीटर, पण मला कमीत म्हणजे मोठ्यात मोठ्या लांबीचा पीस पाहिजे, तुकडा जो आहे प्रत्येक तुकडा. 2चं होतात, 2चं पण बसतं आहे. असा तो विचार कर. 3चं होतं आहे, 3चं पण बसतं आहे. मग त्याला फील झालं तिथे की 3 डिव्हाइड इकडं करतोय, 3 इकडं पण डिवाइड करतोय. आणि मग तो सडनली मला म्हटला की पप्पा याच्यात GCD आहे. बस म्हटलं, तो जिंकला, तू सोडू नको प्रॉब्लेम म्हटला होता पुढचं. असं ते इन्कल्केट करायला लागणार आहे मॅथमॅटिक्स अंडर हायस्कूल लेवलला, हे मला सांगायचं.
भाषेचा एक प्रश्न आहे, भाषा समजत नाही. विभाज्य कोड आणि विभाजक कोड याच्यातच खूप हे झालं.
पण इंग्लिशमध्ये बोललं तर
इंग्लिशमध्ये आता ते तसं होत आहे का भगवान,
हा इंग्लिशमध्ये कळत नाही. विभाज्य हे तर
फार अवघड झालं. मराठी माध्यमात तर ते फारच बिकटच आहे.
नाही, पण सर जे म्हणताय ना की शाब्दिक उदाहरणं समजायला त्रास कमी होतो, कारण ते आपल्या लँग्वेजमध्ये नसतं. म्हणून अदरवाईज शाब्दिक म्हणजे प्रॉब्लेम समजायला तुम्ही ऑब्झर्व केलं असेल सर, म्हणजे हे ट्रू आहे की नाही माहीत नाही, पण मराठी माध्यमातल्या मुलांचं गणित जास्त चांगलं असतं, असं माझं जस्ट ऑब्झर्वेशन आहे.
मदर टंगमध्ये, मराठी इंग्लिश म्हणण्यापेक्षा मदर टंगमध्ये आहे ना ते, म्हणजे एक आता मी सुद्धा एक्सप्रेस होतोय मदर टंगमध्येच, मला चांगलं एक्सप्रेस करता येईल, असा फरक आहे थोडा.
आता आमच्याकडे एक प्रश्न होता सेकंडरी इंजिनिअरिंगमध्ये, आता उदाहरण की त्याच्यात असं आहे की डिझाईन सिक्वेन्स डिटेक्टर, गिव्हन अ सिक्वेन्स आणि डिझाईन करा. आता याचं सगळ्यांना येतं. आता प्रश्न असा विचारला आहे की गिव्ह द प्रोसिजर टू डिझाईन सिक्वेन्स डिटेक्टर, तर ते कोणाला चाललं नाही. सगळ्यांनी एक एक्झाम्पल घेतलं आणि ते सॉल्व्ह करून टाकलंय. त्यांना लिहिता नाही आलं की प्रोसिजर काय,
म्हणजे ते ॲबस्ट्रॅक्ट करता आलं.
हा म्हणजे त्यांना लिहिताच नाही आलं की मी काय केलं होतं असं. हे प्रश्न बघा कसे वेगळे. हे आता लेटेस्ट मी तपासलेले पेपर आहे 76, त्याच्यात एकालाही ते लिहितात नाही.
फरक होतो थोडा टीचिंगमध्ये. म्हणजे खूप थेरॉटिकल सांगणं पण डेंजरस आहे इंजिनिअरिंगच्या मुलांना. माझा इंजिनिअरिंगचा अजून एक एक्सपिरियन्स मी शेअर करतो. थेरॉटिकल शिकवणं किती डेंजरस आहे पहा. मला त्यांना सिरीज शिकवायचं होतं. तर सिरीज शिकवायचं म्हणजे मला सिक्वेन्स शिकावं लागणार. आपल्या फॉर्मल मॅथमॅटिक्सच्या भाषेतून सिक्वेन्स मग इन्क्रीजिंग सिक्वेन्स, डिक्रीजिंग सिक्वेन्स, कॉन्व्हर्जंट सिक्वेन्स, बाउंडेड अबो सिक्वेन्स, बाउंडेड बिलो सिक्वेन्स, असं करत मी कोशी सिक्वेन्स, मग ते त्याचं थेरम, सम, लिमिट, प्रोडक्ट, हे करत मी तिथे पुढे गेलो. सिक्वेन्स ऑफ पार्शियल सम सुरू केलं मग, आणि मग तो सिरीज. तोपर्यंत मुलं झोपलेले होते सगळे. कशासाठी चाललंय काहीच माहीत नाही. नुसतं सर आले की 1 2 3 1/n 2/n 3/n असं काहीतरी चाललंय. आणि एक दिवस आता त्यांच्यात कॉमा लिहित होते आणि एक दिवस आता प्लस लिहायला लागले. म्हणजे काहीच कळत नाही मग काय चाललं तर. पण मी एक दिवस काय केलं, मग दुसऱ्या वर्षी मी थोडासा विचार केला परत. म्हणजे मी प्रयोग करतो, दुसऱ्या वेळेस प्रयोग असा केला की काय नाही, पहिल्याच दिवशी सिरीज 1 + 1/2 + सम घ्यायची. ही सम एक्झिस्ट आहे. अजून थोडीशी लांब मोठी सम घ्यायची, ती पण एक्झिस्ट आहे. मग असं इन्फायनाइटली मिनी टर्म्स जर घेत केलो तर ती सम एक्झिस्ट होईल की नाही होईल हे आपल्याला तपासायचं आहे. आणि मग ते तपासण्यासाठी काही अल्गोरिदम आहेत असं मला म्हणायला लागलं. टेस्ट नाही म्हणायचं, त्यासाठी काही अल्गोरिदम आहेत. मग ती रेशो टेस्ट म्हणायचं तर तो रेशो अल्गोरिदम, पण रेशो टेस्ट नाव आहे त्याचं, रूट टेस्ट, अशा मग त्या टेस्ट मला त्या सांगायला लागल्या. थोडी त्यांची भाषा जर वापरली तुम्ही तर ते इझी होऊ शकतं. क्विकली 1 तासात मी त्याची आयडिया दिली आणि प्रश्न दिले सर. मी मुलांना प्रश्नपत्रिकेत पेपरमध्ये पहिला प्रश्न सिरीजचा सोडवलेला होता, कारण त्यांना ते इझी वाटलं, त्यांना कॉन्फिडन्स आला त्याच्यावरचा. मग कधी कधी असं थोडा कम्प्युटेशनल आस्पेक्ट डेव्हलप करून मग त्याची स्टोरी सांगणं हे पण इफेक्टिव्ह ठरू शकतं. त्या टॉपिकनुसार तुम्हाला पाहायला लागेल की अगोदर स्टोरी सांगायची का थेरी सांगायची. त्यामुळे त्याचा असा विचार, म्हणजे टीचिंग हे स्किल आहे तसं पाहिलं तर.
त्याच्यासाठी टीचरला अलाइव्ह असलं पाहिजे.
हो.
मी काय केलं पाहिजे आणि काय बदल केला पाहिजे, म्हणजे जे पण करतोय त्याचा पॉझिटिव्ह आणि निगेटिव्ह घेऊन पुढे जाऊन परत
करेक्ट
स्वतःला सुधरत जाणं.
This is the fact. When you teach, no, by looking at the face of the student, you understand whether you are whatever you are teaching, whether the student is getting or not. जसं सर म्हटले की you were bringing entropy, potential energy, all those things while teaching exactness. तुम्हाला दिसते की भरपूर लोकांनी फिजिक्स कमी केलं असेल, ते पुरे मोर थिंग्स ऑन मॅथमॅटिक्स किंवा केमिस्ट्री, तर फिजिक्स एवढं नसेल. सो बाय लुकिंग ॲट द फेस ऑफ द स्टुडंट्स, अच्छा हे जास्तच मी डीपमध्ये चालले, ओके आय विल स्टॉप, आय विल कन्क्लूड इट.
तेच म्हणतो मी आता. हे एक्झाम्पल
can't be static. You have to look at the face of the students and then you have to change. म्हणून टीचिंग इज अ व्हेरी सिरियस प्रोफेशन इफ यू टीच नाईसली.
तेच आत्ता म्हटलं मी तुम्हाला, अगोदर काय घ्यायचंय ना याचं तुम्हाला ठरावं लागेल, थेरी की स्टोरी. जर त्यांना थेरी माहीत नसेल तर अगोदर थेरी तुम्हाला माहीत करून घ्यावं लागेल. स्टोरीमधल्या काही हिरो माहीत नसतील, जसे की आत्ता इथे पोटेन्शियल एनर्जी वगैरे हे मेन हिरो आहेत त्या स्टोरीमधले, तर ते तुम्हाला असं अगोदर एक्सप्लेन करायला लागतील की याचा रोल काय आहे पोटेन्शियल एनर्जी, त्याचे काय थोड्या 4-2 प्रॉपर्टीज तुम्हाला सांगायला लागतील. मला तेच सांगायचं आहे की तुम्ही मॅथ्स फक्त शिकू नका, थोडंसं इंजिनिअरिंग मॅथ्स शिकवा, असं माझं म्हणणं आहे.
तसं बऱ्यापैकी आम्ही इन्क्लूड केलं आहे आता, म्हणजे एकदम असं नाही आहे की गेलो आणि मेथड स्टार्ट केली. आपण व्हिडिओज पण इन्क्लूड केले आहे. सिम्युलेशनसाठी आम्ही व्हिडिओज दाखवतो की कसं ते अप्रॉक्सिमेट होतोय किंवा 3D ग्राफ कसा जनरेट होतोय, पॅराबोलाइड कसा दिसतोय, सेक्शन केल्यानंतर सर्कल कसा येतो आहे, इंटिग्रेशन घेतोय तर कसं येत आहे.
नाही, तुमचं इनिशिएटिव्ह चांगला आहे. मी हे जनरल इंजिनिअरिंग कॉलेजेस आहेत ना त्याबद्दल बोलतोय, पर्टिक्युलरली इथे नाही बोलत मी.
मी आपल्या गोष्टी सांगते की आम्ही काय करतो आहोत, त्याच्यात अजून
तुमचं कौतुक इथे हेच आहे. मी मगाशीच केलं सरांशी की इथे मॅथमॅटिक्सला महत्त्व देतं हे कॉलेज. हेच माझ्यासाठी असं ऊर भरून येण्यासारखं आहे. मॅथमॅटिक्सला असं महत्त्व दिलेलं इंजिनिअरिंगमध्ये मला दिसलं नाही, आणि म्हणून मला इंजिनिअरिंग सोडून सायन्सकडे जावं लागलं. खरं कारण तेच आहे की असं दुर्लक्षित केलं गेलं आहे मॅथमॅटिक्स विषयाला. अलाइड, मगाशी मी शब्द वापरला, ॲप्लाइड पण नाही, अलाइड सायन्स, असं एकदम पलीकडचं कुठलं तरी. अशी वागणूक नको आहे. पण तुम्ही हा एवढा सगळा वेळ दिलाय, खर्च करताय, एवढं सगळं इन्फ्रास्ट्रक्चर वापरलेलं आहे, मॅथमॅटिक्सची डेव्हलपमेंट होण्याकरता एवढे ब्रेन इथे एकत्र आणलेत, हे खरंच म्हणजे असं खूप आनंद देणार आहे. मला तर राहवलं नाही शेवटी, हे सोडून मला त्या विषयावरती बोलावं वाटलं. म्हणजे
बेस्ट पार्ट आमच्या इन्स्टिट्यूटचा हा पण आहे सर की ते स्टुडंटच्या स्किल इम्प्रूव्हमेंटसाठी तर हे करतेच, मेहनत करते, पण ते फॅकल्टीवरती पण खूप मेहनत करते. नॉट इव्हन मॅथ्स, खूप गोष्टींसाठी ते फॅकल्टीच्या डेव्हलपमेंट.
हे खूपच चांगली गोष्ट आहे. म्हणजे KK वाघचं मी खरंच कौतुक करतो कॉलेजचं, इन्स्टिट्यूशनचं. म्हणजे खरंच इन्स्पायरिंग आहे हे आमच्यासाठी पण. म्हणजे आम्हालाही सर आता विचार करायला लागेल की फॅकल्टीज डेव्हलपमेंटसाठी असं काही करता येईल का परत. पुन्हा एकदा थँक्यू तुम्ही एवढं पेशंट ऐकलं. हां